Welcome to day 1 of 2 of the eBPF Summit. This is our 3rd summit, and just in case you weren't here for that beautiful video intro that we just had, I am Tracy P. Holmes, and I am a technical community advocate at Isovalent. So first off, I understand I'm hosting, and you think the host probably knows what they're doing. I don't. I'm still a newbie. So this is my first, and I mean very first, eBPF Summit, and I am really looking forward to all of the things that I'm going to be learning from all of the great speakers that we have this year. So what about you, Duffy?
Well, I'm Duffy, and I'm a field CTO here at Isovalent. I was actually with you in the most recent one in 2021. It was a really great virtual event, and I'm look forward to a lot more of that this time. We have a ton of great talks, a ton of great content spread out over 2 days, and I'm really looking forward to it.
Great. And also, if you're watching from a watch party, welcome. We're glad to have you here. Now, before we go any further, we're going to talk about a couple of things. Be human, be kind, and follow the COC. So let's start at the top. Be human. I don't know how many aliens we have on here or how many other animals that are watching, but hey, all of us, let's try to be as human as possible. Let's ask questions of all our speakers because all of our speakers have put in a bunch of effort into sharing their talks and their experiences with them. So that's one way that we can say thank you. Now, be kind. Now, I used to say treat everyone like you like to be treated, but that isn't the same for everyone. So while I don't expect anyone to actually break our code of conduct, I'll give you the brief do's and don'ts. They're going to be brief. Here we go. We are dedicated to providing a harassment-free experience for everyone, regardless of gender identity, expression, age, etc. And that definitely isn't the entire list, but if there's ever any doubt, go consult the code of conduct first. And that link is on the slide. That's isogo.2@COC. Now, that harassment-free experience also includes technology choices. So no Linux versus Windows versus Mac, nor Vim versus Emac arguments on my watch. That said, a community is very important to us. Hey, you know our community. Community is very important to us. So do ask questions. I mean that with all of my heart. I'll be asking some myself. We genuinely want you to learn, and we also want you to enjoy yourselves. So if by chance you do find that you're having any issues related to the code of conduct, please email us at summit@ebpf.io. You can find that in the code of conduct. Also, you can contact Bill Mulligan or Liz Rice in our Slack channel. So TLDR, follow the code of conduct, and you can find it again at isogo.2/COC.
Awesome. Now for some logistics. You found today's live stream, but a quick and easy way to remember the URL to it is to go to ebpf.io/summit-2022 day-1, and that will take you to what you're looking at on the screen right now. If you are tuning in tomorrow, you can go to day-2, and that will give you that session. If you go to ebpf.io/summit-2022, that's where you will find a link to all of the scheduled events for both days. And you'll also notice that if you click on one of the events, like one of the keynotes or one of the regular sessions, if slides have been uploaded, we will be able to link them from there. In a couple of weeks, as we get all of the videos processed and put up, we're going to be able to make a link to the video from that session as well. So if you come back and I remember I watched this incredible talk, I want to be able to go watch that again, you'll be able to find it from there or from one of our YouTube channels. The other pieces of it, if you haven't already, this is a great time to join Slack at ebpf.io/Slack and join the eBPF Summit channel. Inside of that channel, we're going to start a new thread for every talk. So here in just a moment, you're going to see a thread pop up for Alexi's talk that's coming up. Inside of that thread, you can ask any questions that you have of the presenter or provide them feedback. Hey, great job, really love to see it, applause, whatever you want to do inside of that thread. As we see those questions for the keynote speakers, so for Alexi's talk here in just a minute, we're going to actually be asking those questions live of the presenter as soon as the talk is over. So it's really important to us that you feel that you can ask those questions live. So as you're watching the presentation, a question pops in your head, put it in the thread so that we can get that asked live of our presenter. The rest of the sessions, the lightning talks and the regular sessions, are not going to include a live Q&A, but there will still be a thread. And so those questions that you ask in the thread will be answered by the presenter inside of the thread. All right. Anything else? Oh, if you're on Twitter, if you're out there, like, being public about what you're doing and sharing your knowledge, which is one of the things I truly love about this community, feel free to tag us at eBPF Summit.
Swag. So we all want you to be a part of all of this. So let's talk about swag. If you travel to eBPF.io swag, you'll be able to find this wonderful Zoom background that you see on the screen, and you're able to download that. You're also able to find Summit stickers and bags and t-shirts there as well. And honestly, if you don't want a Summit t-shirt, you can go find a t-shirt kind of like what I have on. So do that, and actually go buy one kind of like I'm wearing. I kind of want some twins out here. The other thing that we're going to talk about is bingo. Yes, blame that one on Duffy. So let's talk about bingo. So where's Waldo?
Yeah. Also known as how do I get free swag, right?
Yes, exactly. So how we have Where's Waldo? Where this is the B version. So during the streams over the next 2 days, you'll have a chance to find the various EB and B cousins. You'll find a link to the blank grid in the Slack channel, should be posted very soon. And when you complete that card tomorrow, because of course 2 days, post that in the Slack channel. And to start off, you get a freebie, which is I call Tetra B, and that's the B in the middle of that grid.
That's right. Now, eBPF is a very deep product. It goes basically a mile wide. You can hook into pretty much any kind of function or interface in the kernel. It's just a ton of great content. And just like last year, we're going to be talking across a variety of different areas in which eBPF can be used, right? So last year, I think these were sort of the areas that we kind of broke it into. And this year, we had 80 talk 80 talk submissions, and we had 4 themes generally emerge from the talks that we saw. So today, we're going to spend our time on eBPF for networking and eBPF in the real world. And then tomorrow, we're going to dig into eBPF programming and internals and eBPF for security. So keep an eye out for both of those things. So Tracy, do you want to talk to us about the
there we
poll?
go. So yeah, I do want to talk about the poll that I was about to give you. And it's just as I went to go give that poll to you, it deleted itself. So what I'm going to do is walk through the options that we were supposed to go over. And I'll make sure that before the end of today's live stream, I will post that poll in the Slack channel. And what we'll do is tomorrow we'll go over the choices, but I'm going to walk through them really quickly just so you can get an idea of what the poll is about. So the poll is, I'm interested in eBPF because, and look, here's a chance for you all to get involved. I genuinely want to know why you all are interested in eBPF. For example, like I work here, I've been here a few months, I love it, but I'm also genuinely interested in Cilium. Cilium is awesome. I also am very interested in Tetragon. That little bee with that shield just gets me every time. I also want to get involved because I love community. I absolutely love you all because you all, open source is always honest, whether we like it or not. And to be honest, I'm a beekeeper that got lost and I love the bees and bees need to be protected. So later on, like I said, I'll let you know, you can jump over the Slack and in the poll, pick those things that interest you. And if you have additional things or ideas that you want to add, you can absolutely pop them in a thread.
Awesome. So for a quick overview of today's agenda, again, you can go to ebpf.io/summit2022 and you'll be able to see the detail of all of this. But for today, we're going to start with a keynote by Alexei talking about the future of eBPF in the Linux kernel. We're then going to be joined by Adelina Simeon talking about multi-cluster networking with Cilium, who works at Form 3. Then we're going to get into one of our sections, the first being eBPF in the real world. That will include 5 talks. We'll go to our first break. We'll come back, eBPF for networking, 5 talks, another break, and then we're going to actually catch up with Liz Rice and Natalia, and we're going to be going through the first of the CTF challenges, and that'll include the interaction with Kahoot. So if you saw us talking about Kahoot.it, go ahead and create your account if you want to, and you will get a pin for the Kahoot challenge later on, and that'll be the way that you can participate in the CTF today. After that, we go to Daniel Borkman talking about eBPF innovations in cloud native, and then we finish up with Google from hearing from Purvi Desai from Google talking about eBPF and Cilium, and then that'll be the content for today. Tune in tomorrow for like a whole nother amazing agenda. So, Tracy, are you ready to get started?
Yo, I'm ready to get started.
Let's do it. I am. All right. So our first keynote is going to be Future of eBPF in the Linux Kernel by Alexi. And right after the keynote, we're going to be asking your questions live. So make sure that you put any questions that you have in the thread, and that way we can get those answered live. Welcome, Alexi.
Hello, everyone, and welcome to BPF Summit. My name is Alexey Starovoitov, and I'm excited to do the first talk at this excellent conference that every year brings the best speakers in our ever-growing BPF community. Let's begin with a brief look back at the history of BPF. It all began in September 2013, 9 years ago, on this post. We were aiming to build programmable networking in the Linux kernel. PlumGrid was the name of the startup that pioneered this technology. But it was Cilium creators who took that vision to the next level. Today, Cilium provides bridge router NAT as BPF programs, as open source components that community can build upon. Cilium includes many other networking, security, and observability features, all powered by BPF. The takeaway is the ideas are cheap. It's execution that matters. That September month was very active. BPF was proposed as an engine for socket filters, SecComp, as a flow dissector, and even as an Open vSwitch extension. It's interesting to look back at these events and notice that proposals 1 and 3 came through, while eBPF as SecComp is still a hotly debated topic. The BPF integration with OVS never happened though, since OpenFlow hype crashed quickly. Here is another interesting historical quote. It talks about safety and excellent performance of BPF programs. We stayed true to this motto during all these years. But there are two mistakes in this quote. The first, compile BPF with GCC. Well, it's not quite there yet. Everyone is using client compiler while GCC is trying to catch up. The second mistake is our gross understatement of how complex the BPF verifier will be. The algorithm used by the verifier may be simple, but overall, it's the most complex piece of BPF core, and we're definitely going to work on simplifying it. Today, we're celebrating 8 years and 2 days since BPF instruction set became the standard for kernel programmability. What an amazing journey it's been. I was wondering what motivates me to keep working on BPF. Why some developers appear in the community, do exciting work, and disappear, while others stick around for years. I believe it's a shared sense of purpose. The sense of doing something big is what unites us. It took me a while to discover my own mission statement. I discovered it. It is to innovate and enable others to innovate. I learned that the personal mission cannot be created or borrowed. It can only be discovered, and it doesn't change over the years. I knew I liked the code since I was a kid, but coding can be a chore. The innovation through the code is what drives me. It's only the first part. The second part is enabling others is equally important. I've seen people become maintainers of a project and eventually lose interest. The code reviews got slower, which forced developers to leave and the code to be thrown. It's the case of missing purpose in the maintainership. BPF speaks to both parts of my mission statement. It satisfies my own thirst for innovations through occasional coding that I thankfully have time for, and allows me to help other developers to innovate. I see exciting work that people do in the verifier. They create technologies like XDP or apply BPF in other kernel subsystems like human interface devices, scheduler, memory management. Being a maintainer allows me to help them innovate in those areas. And boy, the stats don't lie. We see 50 to 70 emails a day on the kernel mailing list. That's a lot of traffic. The group of 4 BPF maintainers has to read and reply to every single one of them. Without purpose in maintainership, it would definitely feel like a chore. The number of monthly active developers also grows. We're close to 140 at this moment. Notice this is kernel-only BPF developers only. This is not it, of course. BPF technology sparked the innovation in user space. Just look at bpf.io website. It has a list of most prominent objects. It's a long and inspiring list. But back to the kernel. The support for Rust language will land during the next merge window. Eventually, drivers and core kernel components will be written in Rust. Some people wonder, what does it mean for BPF? It's remarkable that BPF and Rust share the same goal: make kernel programming safe. There is a subtle difference, though. Rust Linux is trying to reduce the number of kernel bugs with the help of the language and compiler. But quote-unquote unsafe adapters from C to Rust has to be written and reviewed by humans. It's a full-featured language that is trying to stay safe within constraints. And I suspect they will achieve that goal. The kernel will become safer and easier to program with Rust. In contrast, in BPF, we're using restricted C. It's a subset of C that is not trying to be safe. It is safe from ground up. The BPF-C was certainly very restrictive in the beginning. There were no global or static functions. Everything had to be marked as always in line to force compiler to generate one single quote-unquote function/program. Things have changed a lot over 8 years. There are loops now, global variables and functions. There is a linker and BPF libraries. The support for task, inode, cgroup local storage that is similar to thread local storage we used in user space. But the most important event that happened in the BPF land was the introduction of C language extensions. They made compile once, run everywhere, or core technology possible. Some people think that core only needs libBPF support and BTF type format in the kernel. Not quite. It starts from attribute preserved access index. It's a generic C language extension, currently supported by LLVM BPF backend only. But it can be made to work on any other architecture, including x86, of course. At the early compilation phase, the client represents field access to data structures marked with this attribute as symbolic load store instead of regular load store, which is register plus constant. Later, LLVM BPF backend converts it into normal instruction and relocation information. That type and relocation is what libBPF is using to adjust the field offset. The key takeaway here: the C language extension allows BPF programs to be portable across kernels, even when they look at kernel internals. There are 2 ways to write portable programs. The first approach is to rely on stable API. For networking programs, it's easy to do. To implement a firewall or a router, the BPF program doesn't need to be kernel dependent. It needs to parse and maybe modify a network packet with just a genetic sequence of bytes. Why does the program need to be stable, people ask? Well, because there are many different distros with their own kernels, even within one data center controlled by one company like Google and Meta. There are hundreds of different kernel versions. But the applications can only afford to build and test their eBPF programs on a few kernels. The second approach is to use core technology to isolate the program from data layout changes between the kernels. There are stable BPF hooks where program can attach, like XDP, NTC. Unstable but portable BPF programs can attach anywhere, which makes them a lot more powerful. The set of unstable helpers, also known as K-funcs, is growing. Soon it will be much bigger and feature-rich than stable helpers. One such example is KPTR, or kernel pointer. The stable programs cannot easily interact with kernel objects. They have to isolate themselves through stable layers. Then stable programs, on the other side, can access all kernel objects and soon will be able to stash selected objects like task struct, socket, connection tracking state into KPTR-enabled maps. The programs will be able to allocate their own objects. Here is how it might look like. BPF core type ID local macro will convert C type to BTF type ID, which will be passed to KPTR new helper. Then the verifier will automatically know the size of the type. In this case, the size of struct foo. It will also automatically initialize relevant fields of the structure. It is similar to C++ operator new, but unlike C++, this is true safe C. The safety is enforced by the verifier. For example, the program cannot typecast the return pointer from struct foo to struct bar and access it. The verifier does the type checks. The memory leaks are obviously prevented as well. The program cannot allocate the object and just return. The program would have to stash the pointer into a map of read. The verifier will provide implicit destructors for the object. There is no garbage collection here. When the program stores object in the map and exit, the map destructors will recursively free KPTR's objects too. The program will be able to chain allocated objects into linked list, red-black trees, and many other data structures. We are standing at the beginning of the next phase of the innovation. Crossing fingers, but I think we figured out a way to statically enforce spin lock correctness. The basic idea is that lock and the object it protects are part of the same allocation. The verifier will know which lock protects which linked lists and will enforce that correct lock is taken before operations on the linked list are performed. The linked list head and arbitrary root, as in this example, have to be annotated with types of objects that they will chain. This is achieved with another C language extension. It's called BTF type tag. We will provide a helper macro underscore contains in this example. The client will store the annotation in the program code, and later the verifier will use it to enforce safety. I do believe it's mind-blowing and very exciting. Back to Rust and BPF comparison. Rust kernel modules are certainly a safe alternative to traditional kernel modules written in C, while unstable BPF programs are getting close to be seen as safe and portable kernel modules. Portability may not be a concern for Rust community right now, but if it is, it would be interesting to see what Rust community will do to make Rust kernel modules portable. I suspect it will require Rust language extensions. And we as a BPF community would love to share the lessons we've learned and tricks that we do. If BPF can enable further innovation and Rust, it will be exciting. There are plenty of other BPF features we are thinking about. One of them is assertions. The BPF users complain about the verifier non-stop. It's the most dreaded gatekeeper. The users believe that the verifier is too dumb to prove the safety of their programs. So, well, we're thinking, all right, let the users tell the verifier what they believe the bounds and conditions of the programs are. The verifier will assume that the assertion is true and will proceed to verify the rest of the program. But it will also insert a runtime check of that assertion. If it fails, the whole program will be aborted. It should be rare, assuming the user is correct. The obvious challenge here is how to unwind the stack and terminate the program safely. Dual compilation of the kernel itself into x86 and BPF at the same time is another interesting idea. It will allow inlining of kfuncs into program, live patching, and so on. Imagine you want to implement a memcached in a kernel with one BPF program per connection. If the kernel can run thousands of instances of the same BPF program, each program can process requests completely synchronously, while the BPF intro will schedule them in one kernel thread. So it's fibers in a kernel. Crazy, maybe not so crazy ideas, but we're out of time. Thank you for listening and for innovating.
Alexei, thank you for that informative talk. You really have, quite a bit of history to share with us, and I also really appreciate your mission statement. To lift others up, and to help, to help further this goal together. I think we are always better together. So it's great. It's great to see that.
Thank you, and welcome everyone again. I think regarding the mission statement, I think it's actually very important for all projects, not only BPF to talk about. I think this is what unites us. This is what brings us together. That's why we love what we do.
Yeah, exactly. Awesome. Well, we have a few questions from the audience. Let's bring up the first one. So we have a question from Jeff Spalletta. Oh, I love the crustacean emoticon there on the bottom. It says, now that Rust has a feature in the kernel, will the future include BPF programs written in Rust? Now, the way I interpret this question, you did speak to this in your slides, but I think that one of the ways that this could be turned a little bit would be, in that eBPF is an extension of the Linux kernel directly. Could Rust also be used in this way eventually if it were to get pulled in, or is it just that you can write modules and that sort of stuff, like drivers and those sorts of things in Rust?
I think that will definitely happen. There is already a project called Aya that's conversion from, there is a compiler that converts from Rust to BPF. And the further we go, there will be, I think, more languages will be used to compile into BPF instruction set. So BPF itself, it's can be seen as an extension to the C. It's a safe C on one side. It's a new language. And on the other side, it's an instruction set, and any other language can compile to it. So Rust, I think, will have there are benefits, of course, and there are challenges as well. Some of it I've alluded to is portability is still a question for Rust. It would be interesting to work with the Rust community on it. And the whole interop with C will be another interesting challenge. But if because of BPF ecosystem, because of BPF as a technology, we'll keep evolving C as a language, it might actually get closer to Rust. And interop between kernel BPF-C and kernel Rust will actually become easier.
That's pretty awesome. Yeah, I can see how that might eventually work. Question number 2. So from William Finley, we have, are there any planned or recently released eBPF features that you're especially excited about? I think I'm the most excited about the stuff that's currently being discussed in the mailing list, which is a safe locking, memory allocation inside BPF programs, linked list, and red-black trees. I think it's a new way of thinking about data structures in BPF. That's why I'm so excited about it. In the past, we had maps as a data structure in programs as two different abstractions, whereas what is happening right now with this new addition of linked list and arbitraries, I suspect some of the new new data structures like maps will appear more natively, like the way you create them in C. So instead of separating them through the FD, there is a file descriptor to the map, they will be more naturally integrated into the control flow of the program.
Go to me for time. Hello, everybody. That we had a small glitch, but thank you for asking those questions. Before I move to the next keynote, the poll. I fixed the poll, so I'm about to throw that in Slack now. And you all answer those questions as much as you want. Now, our next keynote will be multi-cluster networking with Cilium at Form 3, and that's with Adelina Simeon.
Hello, everyone. I'm Adelina Simeon, and I'm a tech evangelist at Form 3. We are proud to be Cilium end users, so I'm really excited to be part of this year's eBPF Summit. Today, I will present to you an overview of how we use Cilium for multi-cluster networking on our platform. First off, let me introduce who we are. Form 3 are a payments technology provider who work with some great customers. We offer a fully managed payment solution that provides a simple and easy to integrate API for our clients. Simply put, we make our customers' lives easier as we take care of all of the complexities of managing payments securely. Our teams are currently working on the multi-cloud project, which has been rolling in phases since early 2021. Our payments platform is written in Go and built with cloud-native technologies such as NAT, CockroachDB, and of course, the focus of today's talk, drum roll please, Cilium. We have been growing and scaling since 2016 with a fully remote team of over 250 engineers across the locations you see here. There are three main aspects of challenges to working in the world of payments that inform a lot of our technical and architectural decisions. Firstly, our platform processes many transactions with an unlimited number of users. All our services must be able to serve traffic at large scale. Secondly, we must maintain reliability SLAs for our clients. We need to handle outages without loss of data or repeated data. We cannot lose money in thin air or invent money either. Lastly, the external payment services that we integrate with update their endpoints and requests periodically. It can be difficult for a small team to maintain all these integrations, which is one of the key concerns that we take care of for our clients. So let's have a look at an overview of how we use Cilium at Form 3. We've been using Cilium in production on two projects, our FPS gateway and our multi-cloud platform. Our teams have been working with Cilium since 2020, and it's been a great learning process that we're excited to share with you today. Our multi-cloud platform will give our clients the choice to run in any of the big three cloud vendors and is due to go live in 2023. Cilium is currently running in 3 clouds and 2 data centers for a total of 6 production clusters. While Cilium provides a wide variety of functionality for networking and security, we currently use it for egress control, network visibility, DNS, and cluster meshing. So, our platform is deployed across 3 clouds and 2 data centers with 6 Cilium installs, 1 for each of our production clusters. We can consider our platform consisting of 2 separate networks, the Payment Services Multi-Cloud Network, and the FPS Gateway Network. These networks pass information between each other. Due to regulatory requirements around leased lines, we had to host our FPS, or Faster Payment Services, gateway services, in 2 data centers running bare metal Kubernetes. These services run on free Kubernetes clusters with one in the cloud for replication. The data centers are clustered using Cilium cluster mesh, allowing us to easily load balance and share information between the data centers. On the multi-cloud side, we have payment services in AWS, GCP, and Azure deployed on the managed Kubernetes offering of each. All pods can talk to all pods through the highly available connections provided by our data centers. We could connect via VPN, but that could potentially suffer from unpredictable latency and bandwidth. Instead, we opted to make use of the highly available connections to our data centers, as we already had these in place for our FPS gateway services. These connections have redundancy and failover built into them, so would already satisfy our connectivity requirements. Then we allocate CIDR blocks to our stacks. The edge routers in the data centers have high-level routing and forward the traffic to the correct cloud based on these. We manage CIDR blocks for all of our stacks so that they do not have any overlaps. As our ranges are very wide, there is lots of room to expand and spin up more environments as we grow. Each cloud provider has hybrid network connections which connect to the public cloud with our private cloud. On the cloud side, there are transit gateways which can further route the traffic to the correct service. The cloud vendors have Kubernetes CNIs which allow native routing, allocating IP addresses to each pod. Cilium secures our cloud solutions using network policies and supports CNI chaining to allow us to leverage native routing on the cloud vendor CNIs. All this together gives us very fast connections between our clouds. One thing to note is that our public cloud workloads are not meshed, as that was not a requirement for our projects. So why did we choose Cilium for our platform? Firstly, it is open source and cloud agnostic, providing a wide variety of functionality such as connectivity and load balancing across the clouds. Secondly, it provides detailed observability with Hubble, which was specifically written for Cilium. Its metrics also integrate well with Prometheus and Grafana, which are technologies we use on our platform. Finally, Cilium is integrated into Kubernetes and provides networking and security at layers 3, 4, and 7. Its network policies allow us to easily secure our multi-cloud platform. We considered other alternatives for our networking solution, but there is no product out there that provides the same functionality. The fine-grained control that Cilium provides with pod identities, as well as the ability to establish connections without sidecars, allows us to build highly performant multi-cluster connectivity. Finally, we can share some of our Cilium setup details. We install Cilium using the official Helm chart. We don't set up Cilium with Flux, our CD solution, because it is advised to be installed before the worker nodes join the cluster. For that to work, we install it right after the cluster is provisioned and before the worker nodes join the cluster. As we rely on fine-grained control of pod siders, we use the cluster pool IPAM mode on Cilium configurations. Hubble is built on top of Cilium and eBPF, giving us visibility of our networking infrastructure. Our teams leverage this amazing technology to debug and observe our stacks. Cilium offers a transparent encryption feature to fully enable encrypted pod-to-pod communication. There are two possible ways of setting that up, IPsec or WireGuard. We chose to use IPsec due to better performance. We configured Cilium to use IPsec-based transparent encryption using Kubernetes secrets to distribute the IPsec keys. After this configuration is complete, all traffic between Cilium managed endpoints as well as Cilium managed host traffic will be encrypted using IPsec. You can read about all of these configurations on the excellent Cilium documentation. To summarize, Cilium allows us to seamlessly deliver multi-cluster networking on our active-active multi-cloud platform. By leveraging it for both our FPS gateway and multi-cloud project, our engineers need to support and understand only one technology. Simply put, Cilium is the company standard for networking and security at Form 3. It has allowed us to secure access to our environments and gives us the possibility to mesh our cloud services in the future. This brings us to the end of my presentation. Thank you for listening and for the organizers for inviting me to share Forum 3's story at eBPF Summit 22. I look forward to taking your questions as well as discussing more online. Please don't hesitate to reach out to us on Twitter at Form3Tech. We'd love to chat and make friends. Bye!
You absolutely heard Adelina. If you'd like to chat and make friends, reach out on Twitter. Also, whatever questions we don't get to today live, absolutely keep asking in Slack. That's what Adelina is here for. So before I ask the first question, I have to say, if you ever do determine how to create money out of thin air, please give me a call.
You'll be the first to call.
Thank you so much. All right, let's bring up our first question. Oh, nice. It's from Liz. All right, cool. So, our first question is, what are your plans for multi-cloud?
So the multi-cloud project or cloud agnostic project has been super important for Form 3, so we can give more options and more resilience to our clients. And as I said, this project is due to go live in 2023, and we've been working a lot with being able to serve traffic in any of the big three cloud vendors, and Cilium has been a really important part of that. The project, I've done a couple of talks about the project in general, which you can check out at other conferences. But yeah, it's a work in progress still, and we're like really, really excited to be able to run our platform in multi-cloud.
Nice. Before we bring up that next question, if someone wants to find those previous talks, can they find them? Like, if they find you on Twitter, would they find them? Okay.
Yeah,
All right. Awesome.
definitely.
So if you want to know about those previous talks, head to Twitter. All right. Question 2. This is from Chris. How many clusters are typically clustered together in your Cilium cluster mesh?
Yeah, so this is an excellent question. As I said, we use Cilium Cluster Mesh for our FPS Gateway project. So, and that contains 3 clusters. And we are using it, so it's two in the data centers and 1 in AWS. And, using Cluster Mesh, we're easily able to network those together and make sure that all of the information is communicated reliably between them.
Okay. And on building on top of that, that brings us to our third question, which is from Andrew. Why do you only run FPS gateways in AWS and not Azure and Google?
So we don't have to. The FPS project predates the multi-cloud project, which we're currently working on. So that's why we decided before. I didn't show you like a historical version of the platform, but it was originally built in AWS. So this is why the third leg of FPS Gateway is in AWS, but we are looking into possibly hosting it in Azure and Google Cloud, which are the other 2 clouds that we want to support. But yeah, it's just because historical reasons and just that's the way that we implemented it so far. And also we need to have the FPS gateways in data centers due to regulatory concerns. So we couldn't put like all 3 in the clouds.
Okay. Oh, I like that answer. Okay. Legal reasons, regulatory and legal reasons is your answer.
Yeah, due to FPS.
All right. I know that there are tons. I'm looking at the questions continuing to come into that thread. So instead of picking one, because they all look very interesting, I'm actually going to shoot things back over. Well, before I do that, Adeline, do you have anything else you want to add?
We are gonna go back and write answers on Slack as well. And
Okay.
some of the engineers are gonna give me a hand as well, and we'll make sure to get some really good answers in there.
Nice. Thank you, engineers from Form 3. I appreciate that. So that was wonderful. Thank you so much for joining us. And Duffy, I'm throwing it back to you.
Awesome. That's our first 2 keynotes out of the way. And the next thing we're going to go into is our eBPF in the real world section. This will include a number of lightning talks and a number of regular sessions, which means that we're not going to be asking questions in a live Q&A after each session, but we will have a thread for each session. So if you have questions about them, it's a great way to provide feedback. It's a great way to keep people motivated. So if you have questions, make sure to drop them into those threads, and our presenters will be available to answer those questions in the Slack. Our first presenter is Mr. Arthur Chow. He is going to talk about large-scale cloud-native networking and security with Cilium eBPF. 4 years of experience with Trip.com.
Hello, I'm Arthur from Troubleshooting, and I'm glad today to have this opportunity for sharing our production experiences with Cilium eBPF for cloud-native networking and security. The agenda, first of all, a very brief intro to the cloud infra at Troubleshooting, and then our practices around Cilium, and then some advanced troubleshooting skills that might be helpful but rarely talked about. For the time limit of this talk, some technical details have omitted, but you can find them in our blog post that I think will be published today later. Trip.com is a one-stop online travel agency with 400 million users worldwide, providing booking services such as flights and hotels. The cloud team is responsible for our infra over the globe. This is a more detailed view of our cloud infra. In the bottom, we have data centers and several public cloud vendors. Above this is our orchestration systems for bare metal, virtual machine, and container. One layer up is the continuous delivery platform, and at the top are our business services and corresponding middlewares. In the vertical direction, we have security and management tools at different levels. The cloud scope is in this box. Some specific information. Most of our workloads now run on Kubernetes. We have 3 big clusters and several small ones with a total 10 kilo nodes and 300 kilopods. Most nodes are blade servers, so which run with 4.19 or 5.10 kernels. And for inter-host networking, we use BGP for on-premises clusters and ENI for self-managed clusters on the cloud. So the second part, Cilium attribute.com. This is a simple timeline of our rolling out process. We started investigating cloud-native networking in 2018, and our first Cilium node rolled into production in 2019. Since then, all kinds of our business and infra services began to migrate to Cilium transparently. And in last year, with most online businesses already in Cilium, we started a security project based on Cilium network policy. Now let's look at some customizations. The 2 Kubernetes clusters are shown here. First, use Docker Compose to deploy Cilium. Second, assign each agent a dedicated certificate for Kubernetes authentication instead of the shared service account by all agents. Third, we've helped to maturate the Cilium's RSys log driver and have sent all agent logs to ClickHouse for analyzing and troubleshooting. Fourth, use few patches added to facilitate business migration, but this is not that general, so we didn't upstream them. And next, use BERT as BGP agent. And last, we developed a new multi-cluster solution called Kiwi Store Mesh. More on this later. Now the optimization and tuning parts. As mentioned just now, the first thing we've done is to decouple Cilium deploy from Kubernetes. No daemon set, no config map, all the configurations needed by the agent or on the node. This makes agents suffer less from Kubernetes failures, but more importantly, each agent is now completely independent in terms of configuration and upgrade. The second consideration is to avoid retry storms and burst starting, as requests will surge by 2 orders of magnitude or even higher when outage occurs, which could easily crash or stack central components like Kube API server and Kiwi Store. We use an internally developed jitter plus back-off mechanism to avoid such cases. The jitter window is calculated according to cluster scale, such as for a cluster with 1,000 nodes. The jitter window may be 20 minutes, during which window each agent is allowed to start one and only one time. Then backed off if failed. Besides, we also assign each agent a dedicated certificate, which enables Kubernetes to perform rate limiting on Cilium agents with APF. Trip.com provides online booking services worldwide, so at any time of any day, business service down would lead to instantaneous losses to the company. So we can't risk letting foundational services like networking to restart itself by the simple fast failure rule, but favor necessary human interventions and decisions. In cases like Kube API server or Kiwi Store failures, we like Cilium to be more patient. Just wait there and keep the existing business uninterrupted and let system developers and maintainers decide what to do in the next. Faster failure and automatic retries will just make things worse in such cases. The next thing I'd like to talk about is scale. Depending on your cluster scale, certain stuff needs to be planned in advance. For example, identity relevant labels directly determine the maximum identities you could use. Also, there are parameters that needs to be tuned according to your workload throughput, such as connection tracking table. Another important thing is performance tuning. Cilium includes many high-performance options, such as SocOps and BPL host routing. And of course, all these features need specific kernel version support. Besides, disable some debug level options are also necessary. The last aspect I'd like to talk about is observability and alerting. Apart from the metrics data, we also collected all agent logs, so we could alert on abnormal metrics as well as agent errors and warnings. Besides, tracing can be helpful too. More on this later. Now let's have a look at the multi-cluster problem. For historical reasons, our business are deployed across different data centers and Kubernetes clusters. So there are inter-cluster communications without layer 4 or layer 3 border gateways. And this is a problem for access control, as identity is a cluster scope object. The community solution to this problem is cluster mesh, as shown here, which requires every single agent to connect to every query store in all clusters, effectively resulting in a peer-to-peer mesh. While this solution is straightforward, it suffers stability and scalability issues, especially for large clusters. In short, when a single cluster down, the failure would soon propagate to all the other clusters in the mesh, and eventually all the clusters may crash at the same time. Essentially, this is because clusters in cluster mesh are so tightly coupled. Our solution to this problem is very simple in concept. Pull metadata from all the remote query stores and push to the local one after filtering. The 3 cluster case in the right show this concept more clearly. Only query stores are involved. In cluster mesh, agents get remote metadata from remote query stores, not they get from the local one. Thanks to Cilium's good design, this only needs some improvements to the agent and operator, and we've already upstreamed some of them. A query store mesh operator is newly introduced and maintained internally currently. We'll devote more efforts to upstream it in the next 2. Besides, we've also developed a simple solution to let Cilium be aware of our legacy workloads like virtual machines in OpenStack. This solution is called Cilium External Resource, CER. Please see our previous blogs if you are interested in. Now let's back to some technical stuff. The first one, debugging. Delph is a good friend, and our Docker Compose way makes debugging more easier. As each agent is independently deployed, commands can be executed on the node to start, stop, reconfigure the agent. We've spotted several bugs in this way. Another useful tool is BPF trace for live tracing, but note that there are some differences for tracing a process in container. Anyway, after locating the target file and check out the symbols inside it, you can initiate user space probes like this and print things you'd like to see. The next one is BPF tool. Now consider a specific question. How could you determine if a Cilium network policy actually takes effect? Well, there are several ways. The first, query Kubernetes. No, that's too high level. Then check out endpoint status. Is the user space state and still too high level? Check out BPF policy with a Cilium command. Well, it's indeed a summary of the BPF policies in use, but the summary code itself may also have bugs. The most underlying and trustful policy state in the end is the BPF policy map in kernel. We can view it with BPF tool. But to use this tool, you need to understand some Cilium data structures first, such as how an IP address corresponds to an identity and how to combine identity, port, portal, traffic direction to form a key in the map. BPF tool also comes to rescue in emergency cases, such as when traffic is denied, but your Kubernetes or Cilium can't be ready to apply any changes. In these cases, you could insert and allow any rule like this. The last skill we'd like to share is manipulate queue store contents. Again, this needs a deep understanding about the Cilium data models, such as with the following 3 entries inserted into queue store, all the agents will be notified that there is a pod created in Kubernetes cluster 1 and namespace default with IP address, node name, node IP labels, identity information in the entries. Essentially, this is how we injected our virtual machines into Cilium scope in our CER solution, and is also the basis of Cilium network policy. But manipulation of queue stores and as well as BPL maps are dangerous, so we do not recommend to perform these operations in production unless you know what you are doing. In the end, a quick summary. We've been using Cilium since 1.4 and have upgraded all the way to 1.10 now. It's supporting our business and infra-critical services, and with 4 years experiences, we believe is not only production ready for large scale, but also one of the best candidates in terms of performance, feature, and community. In the end, we'd like to say special thanks to Andre, Daniel, Joe, Martinez, Paul, Quentin, Thomas, and all the Cilium guys. The community is very nice and has helped us a lot in the past. Okay, that's all. Thank you.
Incredible presentation, Arthur. Thank you very much for that in-depth troubleshooting piece. Like I definitely learned some stuff there, and I really appreciate you getting into the detail of like looking at BPF maps in the troubleshooting section there. Our next talk is going to be eBPF, the Capital Markets Perspective by Alex McKenzie.
Okay, hello everyone. I'm Alex McKenzie, and I'm here to talk about eBPF, the capital markets perspective, and specifically the venture capital markets perspective. Now, maybe as some of you know, I've been in the weeds of eBPF for some time now, but don't expect to be as in the weeds as the majority of this audience. What I perhaps do expect to know something about, though, is the world of venture capital, and more specifically, how the business model of venture capital impacts our thinking when it comes to investing in new technologies like eBPF. The second point that I'm going to talk about is really the idea that I subscribe to, the idea that venture capital is a business of aggregation. If we do our job right, and if we listen well enough, we should speak to the smartest people on specific domains, aggregate those learnings, kind of build a worldview, and then invest in that worldview as a result. So what I'll do is share some of the learnings that I've gathered along the way. So yeah, a little bit more about me. I'm a partner at Tapestry. We're a venture fund that invests in technical repeat founders across Europe and the US. So think of companies like Hopin, Pitch, Crossbeam, Standard Cognition. But then beyond the world of investing, I still spend a lot of my time writing code, or at least hacking code together. If you want to see that, you can check out my GitHub, lambast accordingly, that's fine. But what I also do is write a number of technical primers on technologies that I'm excited about and that I think others should be excited about too. So I've written about eBPF, which is kind of why I'm here, but also on federated learning, a number of JavaScript runtimes, and then other posts like how to build developer tools that developers love. So yeah, agenda. Firstly, we're going to talk about, again, the business model of venture capital. We're going to back that up with a bit of data. We're going to talk about the world or industry of infra, how the public markets view infra, how the private markets view infra. Then we're going to jump into the meat of the presentation, which, yeah, is eBPF. We're going to talk about market views. I'm going to share the investment frameworks that we use, or at least some of them that we use when thinking about investing in a new technology or ecosystem. I'm going to talk about the what now in eBPF. What do I think is exciting to invest in next, or at least watch? And then the why now. Why is now the time to keep an eye on eBPF? So firstly, as maybe some of you know, venture capital is a business of power laws. Really what that means, if you think about it as an individual fund level, is that really 1 to 2 to 3 of your investments are expected to drive the majority of the returns of your fund. You can zoom out and you can then actually look at that across the general venture market. So you can stack a number of firms next to one another. And again, what you'll see is an exponential curve here, where a small minority of the funds return the majority of the capital. Horsey Bridge has provided some data here, which kind of really shows that off. So as you'll see, across 1985 to 2014, 6% of the investments made returned 60% of the capital, right? Venture capital is a business of outliers. But again, what you'll see is the best performing funds, it's not as if they had fewer failures. Failure was actually more common. But what they did is they just had much greater successes, right? So this is the interesting thing about venture, because other asset classes are far more about managing your risk, mitigating risk. The idea of losing money at all is not good, right? So again, venture capital is just an interesting asset class. We aim for outliers. If we think about the 6%, I mean, of late, really it has been tied to this category of infra. And again, I've seen a lot of definitions for infra. My favorite is from a friend of mine, Sam Crowder, where he says, infra is anything that helps in the development, delivery, and security of software. Right? So think of HashiCorp, SentinelOne, Snowflake, Cloudflare, etc. And why these companies are so attractive is that they're really top tier performers in a number of the metrics that we would use as investors to evaluate how successful SaaS companies are performing. So if we think of something like net dollar retention, which again is the amount of, or the increase or decrease in revenue from one cohort across one time to another, we'll see that we're seeing incredible rates here, right? 173% in the case of Snowflake. If we, just to kind of make that more concrete, think about Snowflake, for example, and think about that from one cohort, they're making a total of $1 in revenue. They've got 173% net dollar retention. So what that means is that that $1 will turn into $1.73. And how that happens is that over a period of time, that customer base will expand, right? They'll opt into more expensive plans. Some of them will churn, they'll stop being customers. Some of them will downgrade, but in net, you'll see that again, Snowflake is turning that $1 into $1.73, and that's a pretty attractive position to be in. We could speculate all day about why these companies could do this, but I think the most obvious reason is that it's incredibly painful to rip out your infrastructure. Everything about your application and business runs on this infrastructure, is intertwined within this infrastructure. So again, pretty difficult to rip that out, and I empathize with any of you that have had to deal with that. I just thought this was interesting. Again, you see a power law among power laws here, right? Cloudflare, Datadog, SentinelOne, GitLab, etc. We're all outlier successes, and yet Snowflake is an outlier among these outliers. And you'll see that the private market really is no different, right? Again, these infrastructure businesses are built on the same fundamental properties that make them such great businesses. So a congrats to Wiz that went from 1 to 100 million ARR in just over a year, right? Surpassing companies like Deal and Ramp, UiPath, Slack, another infrastructure peer, Twilio. Okay, so where does eBPF come into this whole narrative? Well, the best description that I heard from my conversations came from an engineer from one of the main observability players, and they said that the correct way of doing things, eBPF is the correct way of doing things. It's correct and precise innovation. And kind of what he means here is that eBPF is infra plus plus, right? It is the best way to do infra. We can do APM, we can do runtime observability, we can do API observability. eBPF, again, there's technical trade-offs, of course, but in a number of ways or times, eBPF is the best way to do it. That could be because, again, your code as an eBPF program can be pretty performant when it's running in kernel space versus user space. That can be because your eBPF program has grander access to a bunch of low-level resources versus, again, the user space application. There's a number of reasons. And again, I've heard a number of them articulated. If we focus firstly on ground cover, the founder said something super interesting to me, which is that if you think about general observability solutions, many of them run in user space, right? So we're relying on a user space application to watch other applications in user space, which kind of begs the question of who is watching the watcher in this case, right? And their whole take is that they can actually use eBPF to watch user space. And all of a sudden you kind of solve for that watching of the watcher problem. Again, I think Secret was doing something super interesting as well, where they were thinking about layer 7 traffic monitoring and not really being able to use something like TCP done for that. But again, eBPF enabled them to do that. Right? They were able to do better traffic monitoring and hence better API observability as a result of eBPF. It's the correct way of doing things. It's correct and precise innovation. So yeah, these are just a number of frameworks that we use when we're thinking about new technologies. And I had to get a dig in at the JavaScript frameworks when I had the platform. But yeah, first one we use is, is this technology incremental or is it really building something new as a category defining? And kind of what we ask ourselves is, what can or should now be done at scale because of a new technology? So if you think about something like containers, yes, they were incredible, right? But what happened as a result is that you had a number of vulnerable images that, again, then a solution was required as a result of this new technology or new paradigm. A new solution was required to actually monitor these images, scan them, and make sure that those images that you were using were safe and reliable. So again, new technology resulted in a new company being built in a large space. That's attractive. What's not attractive is companies that effectively are features. They're not categories. Another framework that we use is the idea of counter-positioning, and I'm told this is something that is taught in many MBAs that I unfortunately missed, but really what it means is that on a fundamental level, why is an incumbent typically not able to adopt the same business model or approach that you can adopt? Because inherently they've made a series of strategic decisions that have stacked upon each other that just fundamentally stops them from being able to do what you do. The kind of canonical example here is Netflix and Blockbuster. Right? Blockbuster built this whole retail set of chains and stores. It was a large retail business. It wasn't within them to then actually start sending media, sending DVDs, sending videos, whereas Netflix was able to do that straight off the bat. They didn't have to manage all this CapEx. And again, that enabled them to move a whole lot faster before Blockbuster could catch up. And we kind of know how that one played out. We also like to ask a question specifically for infra, which is just, where does big cloud suck? I think PaaS is a good example here. And you can find where big cloud sucks. There's probably a big business to be built around it. Another idea that we use is increasing returns, right? Will every unit of positive scale result in a greater marginal return? So another way of saying that is, or another example of that is something like network effects, right? Each new user within the network makes the network more valuable, which in its results in more people joining the network. Each unit here has made the ultimate marginal return larger. And then one that we use a lot and that I quite like is the idea of upstream, right? So you could be a new technology that's used further up the stack than a bunch of other large players. And then as a result, can you kind of claim ownership on those other areas of the stack or chain in time? And I do think to kind of level the playing field with JavaScript frameworks, Vercel has done this, right? If you look at Next.js, write your code, use Next.js, and then of course, deploy with Vercel. It just makes sense, if not for conveniency, for a bunch of other reasons. So then what now with eBPF? I had the pleasure of meeting with one of the, ostensibly, one of the greats of venture. I asked this person, how do you think about being a fantastic venture capitalist? And this person said, all you got to do is do the best deals. And I kind of think this same way, that if you were to ask somebody that knew nothing about the world of venture capital, what makes you a good venture capitalist, they would probably say, I don't know, probably invest in the best companies, do great deals, right? And then you get all this middle in between of all this complexity. But so then I apply this framework also to the world of security, right? And this is where eBPF ties in, which is like, if you had to ask somebody what is the idea of security broadly, it's to stop bad things from happening, i.e. runtime enforcement. But we do a whole bunch in the middle of observability, triaging, escalation, training models to infer tickets that we should flag, etc. When really what we're trying to do is just stop bad things from happening. We're trying to do runtime enforcement. So I'm super excited about what the folk at Standalone are doing and what they have open sourced when it comes to runtime enforcement. Otherwise, I'm excited more broadly just about thinking about eBPF programs as modules, right? Deploying pieces of code as eBPF programs and benefiting from performance results that come from that. And then if we get a bit more blue sky, I think it was Ferris Ellis that thought about or written about the eBPF virtual machine being ported beyond the Linux kernel and into environments like SmartNICs, right? And thinking about all that that will unlock. My general thought on this is that eBPF came from being a result of the constraints of the Linux kernel, right? This incredible technology and platform came from constraints. So I'm pretty excited about the other constraints that will come from eBPF being deployed to SmartNICs, right? So yeah, excited about that. And then the why now for eBPF. So firstly, we've begun to see some exits in the space, right? We've seen New Relic acquiring Pixie. We've seen very recently Datadog acquiring Secret. It's kind of showing the general market that there is a lot of appetite, one, for just acquisitions, which means ultimately capital to investors at some point in time. But two, it kind of shows that the incumbents perhaps aren't in a position to really build these technologies in-house the way they may be in a relative sense to other technologies, right? It's more valuable or far easier to acquire companies to gain that competency. I think that means that there's an interesting opportunity to actually challenge incumbents, right? That's enticing as an investor. I think broadly speaking, the industry has a far better understanding of eBPF, and ultimately, if you have more educated buyers, you have more buyers, right? So that becomes more attractive for us as investors. And just as a small anecdote, I saw a comment or heard a comment from a friend that said KubeCon was basically eBPF and wasn't Con, right? eBPF is occupying more of the mainstream infra mindset, and I think that's pretty exciting. And then technical maturity, right? It's become the point where eBPF has become far more general purpose. Again, this could be because we've got eBPF for Windows now, but more broadly, we say at Tapestry that we like general purpose software, right? Because if your software technology can be used across a broader range of use cases, your market size increases, right? So yeah, I think that's enticing. And then again, a series of eBPF tool chains have also emerged, right? It is easier to build eBPF programs. It's easier to connect them, to manage them, etc. So yeah, that's it from me. Just to reiterate, I invest with Tapestry. We back technical repeat founders across Europe and US. And I mean, if any of what I spoke about today resonates with you, or if you're thinking about building a company, I'd love to talk to any one of you. My email is my name @tapestry.vc. And yeah, looking forward to chatting with some of you.
Awesome presentation. I'm kind of a student of perspective, and so I always love to see the perspectives of people that are outside of my own, like things that are just completely not the way that I think about the world and those sorts of things. And that is absolutely a great talk for that sort of thing. Thank you, Alex, for sharing that. And if you have questions for Alex, remember that you can go into the thread. You'll find it pinned in the eBPF Summit Slack channel, and you can ask those questions there, and Alex can and connect with Alex in that way. That brings us to our very first break. We're going to be coming back at the top of the hour, and we'll be we'll be welcoming Tracy to introduce the next set of talks. I hope you get some stretch and something to drink, maybe a snack, and we'll see you soon.
welcome back from the break. So, before we get started, this is a bingo reminder for you. Have you been bee hunting? How many bees have you captured? Be gentle with the bees, they're our friends. All right, so first things first, I want to give a shout out to the watch parties. The first watch party I want to highlight is in Berlin, and it's so great you all are excited about learning about everything eBPF. Please look at those pictures. Don't they look like they're having fun and being studious? I also want to give a shout out to their host, Microsoft and Polar Signals. We absolutely appreciate you hosting that watch party for us. Now, as always, for our talks, make sure you ask questions in Slack. For our lightning talks, these are not live. However, the questions are still important. So for our first post-break lightning talk, we have Cilium Standalone XDP L4 Load Balancer from Andre.
Hi guys, thanks for joining. In this talk I'll be presenting Cilium Standalone XDP L4 Load Balancer. My name is Ondřej Blažek and I work for a company called Seznam, based in Czech Republic. Before I dive into Cilium, I will shortly describe our infrastructure, how everything works, and well, what you should be expecting from the talk. So initially we have our internet clients, and for some of you who run everything in public clouds, most of the load balancing is probably handled for you, but we host most of our services in our own data centers. So on one side we have our network load balancing based on IPVS. Using IP-IP tunneling, we load balance to one of our Envoy proxies, which then distribute the traffic, load balance the traffic to one of our either Kubernetes or OpenStack clusters where the actual backends are running. So the plan is simple. It's to replace IPVS with Cilium. Thanks to Cilium having the same features as what we use with IPVS, this should be fairly simple. And I'll show you in a minute how you can launch Cilium. Cilium itself is released as a Docker image. So if in case you don't want or don't need to modify anything in the Cilium repo, you can use the Docker image directly and run it, for example, like here in a Docker container. So the important part is here. It's the maglev algorithm, which with regards to IPVS, it's been in the Linux kernel since 4.18, I think, and in Cilium it's since 1.10 release. So it's important for us, so we use it like this. Here you specify a direct server return, a native acceleration, IP-IP dispatch algorithm for the tunneling, and data path mode LB only. We also serve both IPv4 and IPv6 services, so we enable both of these options. So this way you can run the L4LB, and once you have that up and running, you can use its API to configure all of the services. So using a CLI, for example, you can do a Cilium service update. Under ID, you will choose a number. On the front end, you put your virtual IP plus the TCP port. And under backends, we put our Envoy proxies. The important part is a service type, which is a node port, and that one uses the XDP hook. So be sure you have this correctly configured. So once you have Cilium configured, you need some way to announce the IP addresses of each service into neighbor routers. So we use BERT for that. We use BERT systemd service for IPv4 services and BERT6 for IPv6 services. Otherwise, it's the same service. So that handles the BGP announcement, because our infrastructure uses BGP routing protocol. So once you have this, your clients should be able to connect. So this way, you can launch Cilium, and that's what we did. And right after, we started with the testing. So initially, we went for a synthetic test. We decided to run a synflat attack. We knew that IPVS, well, could have some problems with that, and we went for a Moongen packet generator based on DPDK to generate the traffic. We choose just one CPU to generate the traffic, and we randomized some data in the TCP segment so that the total length of a packet is 64 bytes. So that's how we configured the Moongen client. And on the other hand, we had some legitimate client who was sending HTTP GET requests to the same service, and so we wanted to see if everything is successful or not. So then the IPVS was load balancing to some of our backend proxies. And let's see the results. So with 1 million packets per second, well, we were surprised that that it's so close to IPVS limits. But as you can see, one core was already reaching its maximum, and it means we expected to see some packet drops. And that's what happened at the legitimate client output window. So there was a connection timeout from time to time, which was not that often. It was not yet a total maximum of IPVS, but when we went higher to 3 million packets per second, that was the end of IPVS. So this was super important numbers for us, and we saw at the client output that, well, all the packets, all the requests were basically lost, and well, the CPU load just showed 100%. So that was the end, and we had so much expectations for Cilium that actually showed us that it works great. Initially, we started with the same numbers. We started with 1 million packets per second, then with 3 million packets per second. This is not a typo. So we ended at 10 million packets per second because actually at this speed, the CPU load of the L4LB actually showed us something, because before the numbers were so low, it was not worth showing it here. And as you can imagine, in the client output window, everything was successful, and this is a huge success. And you can see it's more than 10 times better for this test than compared to IPVS. So we went higher. We went to 14.8 million packets per second. That's where we stopped, because at this speed we saw multiple connection failures, and it was still not hitting a CPU limit. So this was caused by either the NIC of the L4LB or the router in front, because that it was simply too many packets to handle. But still, we were not hitting the maximum, and this was a huge success. But still, this was only the synthetic test. We wanted to see the proof from production, so we decided to put one node or to take out one node, replace IPVS with Cilium and put it into production, and that's what we did here. So we took out the green one, the green node, we deployed Cilium on it, and we had the other two nodes running IPVS. This is not from the whole production. This was only part of it, because we wanted to see only on a small portion of the traffic how good it is, and you will see it in a minute how good. So just to summarize, from 11:05 until approximately 11:13, all the traffic was handled by the Cilium L4LB. Then we started BERT on the other two nodes running IPVS and stopped the BERT on the Cilium node, so that the traffic is gracefully handled by the IPVS nodes. So then we looked at the CPU load and stopped for a minute, because at one point we were not even sure if we did something wrong, or if what we're seeing is truth. But then we looked closely, and that's when the wow effect really came, because handling 800k packets per second by the Cilium L4LB showed us that it needs only half of a CPU core, compared to the same traffic handled by two IPVS nodes, both of them using 18 CPU cores. Well, that says that we are saving 36 CPU cores when we replace IPVS with Cilium. This was a huge success, and that's what you should actually take away from this talk. Running Cilium L4LB at the driver layer has amazing performance with a very small CPU footprint. I showed you that we saved 36 CPU cores, but that was only a part of our nodes. If we deployed it everywhere, we could save so much more. So the more traffic you're handling, the more CPUs you can actually save. That means you can save so much money, and that's the huge success story of us running L4LB. So with that, I would like to thank you so much for listening, and thanks to everybody involved in Cilium project. Thank you.
Thank you so much, Andre. That was a wonderful talk and wonderful takeaways. So for our next talk, we have eBPF, A Road to an Invisible Network, S&P's Global Network Transformation Journey, and that's given by Guru Prasad.
Hello, everyone. It's an honor for having an opportunity to present at 2022 eBPF Summit. My name is Guru Prasad Ramamurthy. I'm a Global Head of Network Architecture, Engineering and Operations at S&P Global. Today, we'll talk about the role of a network engineer in the Kubernetes world. As app developer role is evolving, so as the network engineer. We will also deep dive into the S&P Global network transformation journey and how we delivered a seamless, secure, and frictionless network experience for our developers in the on-prem world, in the cloud world, and how we are doing this in the Kubernetes serverless architecture world as well. Talking about the company, S&P Global is a leading provider of independent ratings, benchmarks, analytics, and data for capital and commodity markets worldwide. To do this, we operate in 100 offices worldwide, 51 data centers, 4 multi-cloud providers, and 37,000 talented employees. They work round the clock to deliver the essential intelligence to our customers across the globe. Let's talk about the journey of S&P Global. It's an industry-leading strategy. The journey started late 2017, early 2018. Like every large enterprise, we also lifted and shifted all our applications into a single cloud provider. Over time, the strategy evolved, the journey evolved, and we started building our multi-cloud strategy, and we provided a seamless onboarding experience for a multi-cloud environment in order to continue to propel our strategy further, and as well as towards the path of reducing our overall cost of managing and maintaining this infrastructure. And that led into the further conversation of about how do we operate financially very well. And the effort started off about cost reduction. And there are several initiatives that have put around cost reduction by automating the environment, optimizing the environment, as well as adopting the multi-cloud capabilities, and more importantly, deploying more modern and cloud-native Kubernetes architecture that can reduce the cost, that can make our infrastructure and applications very nimble so that we can take the benefit of the overall cloud. And things changed in 2022 with the merger with IHS Markit, where our number of applications have grown more, our number of data centers have grown more, but the team at S&P Global is very hands-on, and they have a very good experience of lifting, shifting, transforming into multi-cloud, as well as deploying the same in the Kubernetes world. So we build this rinse and repeat approach of fast tracking our remaining application migration journey into the cloud using the rinse and repeat approach, and using the same playbook where our subject matter experts who had the past experience are now helping to fast track our remaining applications that came from the IHS into the cloud as well. And because the cloud has advanced from 2017 to 2018 to 2022, the team has gotten good opportunity to also look at, can some of the applications go into the Kubernetes world right up front instead of moving into the cloud first and then moving into the multi-cloud and then moving into the Kubernetes. So the experience, the technology advancement, and the rinse and repeat approach giving us an opportunity to kind of look at various possibilities of fast tracking our remaining application journey into the cloud. But let's talk about what happened to the applications that moved into the cloud 3 years before. The applications that have moved into the cloud a couple of years before have already begun transforming into the Kubernetes architecture. And within S&P Global, we have several business units. Each one of them have taken their charter of transforming their application into the serverless architecture into the respective cloud ecosystem. And network team has been that center and corner of all the conversation in enabling our businesses to transform them into that Kubernetes architecture. Let's talk about a myth buster here. The common myth in the industry is app team can function independently in the Kubernetes world. Like I said in the beginning, as application developer role is evolving, so as the network engineer. The truth and the fact is there needs to be an increased collaboration between the app and the network team in order to run a reliable, secure, and scalable application in the multi-cloud environment. Because if you look at our journey, the application moving into the Kubernetes world or application moving into the cloud world started with single cloud provider. And when you go into the single cloud provider, when you go into the single Kubernetes world, it's a cloud native use cases that's been used within the single cloud provider. But when things become multi-cloud, when the use cases grow, when number of apps are growing, the complexities is growing. So in order to avoid addressing the challenges down the road, hence it is important to engage with the network team ahead of time. Giving them a chair in that Kubernetes conversation, Kubernetes discussion is extremely important to avoid some of the challenges that we will talk in the following slide, so that we can proactively look into those problems and address that with the right solutions and with right answers. This is a high-level multi-cloud container network use case that we will deep dive. As you can see, a customer trying to access our application from outside and the application is hosted in 2 different cloud using individual cloud native services, and as well as using an external service provider to load balance the same. And more importantly, you can see the picture depicts the app needs to talk to another application in a data center, or another service in our SDDC, or another downstream systems in our SaaS. And as well as more importantly, the app needs to talk to all our downstream systems in the monitoring and logging and the observability space. Hence, it is important to create that highway in our Kubernetes world in order for the networking to seamlessly communicate with all this ecosystem and still provide the perfect end user experience. Using Cilium CNI, we built that highway, and that highway today communicates seamlessly with our on-prem, the cloud, and the SaaS, and all our downstream systems in order to make that experience very reliable, very smooth, so that every time the app owner or application developer doesn't have to rethink, re-innovate, or redo, how do I connect to my data in data center? How do I connect my DB layer in a SDDC? How do I connect to my a service in a SaaS? How do I log? How do I observe? So application developer do not have to worry about how do I connect. Rather, using Cilium CNI, the highway is built, the connectivity is seamless in the container world, so that an application across this two large cloud ecosystem using the cloud native services, whereas through the common fabric of the Cilium, we have provided that very seamless and secure connectivity. We'll talk about some of the problem statements in the following slide, how when we were in the single cloud provider using a single native services, and when we started moving into the multi-cloud, how we learned some of the problem statement and how we addressed and using the Cilium CNI. Here are our problem statements, and here is how we addressed and resolved using the Cilium CNI. And this is more important for the organizations that are getting started with the multi-cloud container use cases. The first and foremost problem statement, when we started with a single cloud provider and a single cloud native ecosystem, things were fine. When things started becoming multi-cloud, when so many number of applications moving into the cloud native ecosystem, it's a very common problem that the IP exhaustion starts. And when the problem statement occurred, we immediately said Cilium is a solution. It has an inbuilt VXLAN technology, and using that, we overcome that IP exhaustion issue. And because we were growing multi-cloud speed and adoption has been extremely great at the company, and using individual CNI at every cloud provider creates a lot of complexity, a lot of challenges, a lot of tool chaining. And one of the historical successes within S&P Global, within network team, is simplify and standardize the ecosystem. And we started using Cilium CNI to simplify and standardize the delivery of multi-cloud Kubernetes network services across all ecosystem, so that we don't need to re-innovate the wheel every time, so that our configurations are simplified, standardized, our policies are very consistent across the globe. Thereby, we can achieve a great parity and great consistency across the cloud. And as we started building this, the developers were extremely interested in understanding the overall layer 7 observability. What is happening in each of the world? How is each of the services are communicating? What is the traffic in the east, west, north, south? What's going on? So Cilium provided a greater visibility through their Hubble UI, and we started using the Hubble UI and gave granular access to our each application owner, saying, if you are an application owner, here is the Hubble UI. You can go there and start looking at all the way up to the layer 7 stack, so that they can get a good understanding of how the application is talking. And the great capability that they got out of it is they were able to even see at a process level where their application is communicating, what is being communicated, so that they can make a very good decision with the data that they are getting. And over time, when the applications start growing into the multi-cloud and the multi-cloud ecosystem, multi-cloud Kubernetes, we also saw there is a increased latency due to the sidecar, the feature that's being used in the cloud native CNIs. Whereas in the Cilium world, when we moved there, we started seeing that Cilium does not use the sidecar at a pod level. That tremendously improved the performance and latency between the applications, and that increased the overall experience for our application developer. Network security plays a very critical role in the Kubernetes world, and our network security team plays a very significant role. And as the industry is moving towards zero trust policies, zero trust environment, we were very keen on building that from the grounds up in a proper way. Cilium offered us a great identity-based, DNS-aware, API-aware policies, which gave us an ability to deploy a truly zero trust policy capability at an app layer, at an API layer, at an application layer, at a network layer, so that we can make sure the right level of network policies and application policies are deployed to create the true zero trust environment. And as we are going into the multi-cloud, as we are deploying apps into the multi-cloud, as we are deploying apps into the multi-cloud Kubernetes ecosystem, the true benefit is about high availability, right? In a typical large enterprise, the apps needs to be always available for the end customer. And using the cluster mesh, we were able to design applications at a global services level as well as a shared services level, such as Active Directory, DNS, all of them are shared services. And applications have to be globally available for our customers in over 100 countries. So we were able to deliver that consistent global high availability for our global applications. Encryption played a very critical role, and we used Cilium's inbuilt IPsec encryption capability to do that. And last but not least, the multi-cluster capability played a very critical role in making sure that multi-cloud, multi-cluster use cases are addressed using Cilium cluster mesh. With that said, these are various problem statements that we learned through the evolution of our cloud native journey, and which led us to the position of why we need a simplified, standardized multi-cloud CNI. And Cilium came at the right time with the right solutions, partnered with us, and we were able to deploy very frictionless network experience and provided consistent ability for our developers to deploy an application in AWS, deploy an application in Azure, it could be Google Cloud, anywhere in any cloud ecosystem. The fundamental CNI becomes standard, and then they don't need to reinvent the wheel of how do I configure my IP today? How do I configure my DNS today? How do I configure my DHCP today? Where do I get the IP address? Where do I get the security? Today within S&P Global, we have made the underlying networking service of Kubernetes simplified, standardized, seamless, consistent, and more reliable across the cloud. Whereas the experience of the developer is focused on making their application even more better and put their efforts in the application enrichment and development journey. With that said, I conclude my talk. Thanks once again for the opportunity in the eBPF Summit 2022. Looking forward for engaging throughout the session, and see you again in the future summits and future events. Thank you.
That was awesome. And that Cilium multi-cloud CNI US use case slide and the following advice slide for orgs new to multi-cloud, those were pretty awesome. So now our last lightning talk before our next break will be signed eBPF programs across platform analysis from Dave.
Hi, I'm Dave Taylor, and I'll be talking about signed eBPF programs from a cross-platform point of view. In other words, covering both Linux and Windows and potentially any others. So let's go ahead and get started. All right, so on the top, you see a classic arrangement of components for eBPF, where an eBPF program goes through a couple of different forms, say from source code, if you're using a compiler, to eBPF bytecode, and then finally into, say, native code after it's been JIT compiled. And the verifier's job in the middle there, where it goes from the red line to the green line, is to decide whether that program is authorized to run. That's done by saying, is it provably safe? And is, at that same point in time, is the source of that program actually authorized? And so what do we mean by is the source authorized? Well, this is where the concept of code signing comes in the future, where in the past it might be, oh, is it submitted by root or something fairly simple like that? Okay. Now, just one thing that I consider mostly out of scope for this talk, but there's also been some discussion about is, could you actually do verification as part of that signing process, such that when it gets submitted, that the signature check could also verify that it was verified under the appropriate things? There is some discussions about that too, but I'm not really going to be talking about that. We can take that offline if you're interested in that topic. So with that, we're only going to talk about how you decide whether the program source is actually authorized. So when we look back at different code signing mechanisms, unrelated to BPF or not specific to BPF, right? There's a couple of different varieties that exist already out there, okay? Especially on different operating systems, there's not a one-size-fits-all solution. So for example, since a lot of the BPF community is familiar with Linux, let me talk about Windows first, or at least the Microsoft hypervisor first, which is not Windows specific. And then generally, anytime that you have a type 1 hypervisor, where a hypervisor that's type 1 means it's done underneath the kernel, right? Just because you have kernel code, or you can get root on, or you can get kernel code, doesn't mean that you can run arbitrary code. When you have a type 1 hypervisor that says, for any code page to be executable, it has to be signed by a signature that the hypervisor trusts, a key that the kernel even doesn't have access to. Many times a code signing key will not even be online. It might be off in a back room someplace in an HSM, only accessible through some builder signing pipeline, okay? So what this means is that you can't actually inject, say, dynamic code pages, right, if you're doing this, right, because you'd have to get that signature, and that signature might not be doable at runtime. This does interfere with some scenarios that people actually want to do, say BPF trace, for example. BPF trace, you say, well, I want the admin on the machine to be able to type in some filter, and that gets JIT compiled and then can run at runtime because BPF trace is trusted. Okay, and so that type of scenario and the type 1 hypervisor enforced code integrity seems that they are mutually incompatible. Okay, now we'll talk more about, well, what do you do in that case? Okay, but you'd say that's actually intentionally incompatible. Whereas other techniques like binary signing and volume signing that do enforcement at the OS level rather than at the hypervisor level means there's a lot more flexibility, and things like dynamic code can be supported. So you see some examples of things that fit those three categories, but there may be others across as you look across different OSs and platforms out there. So what do we do here? Well, if the point of this presentation is largely a survey and then what to do amongst the heterogeneity. So a survey of different types of techniques, okay? eBPF programs, as shown in that first picture, can be in various forms over the lifetime, right? So they may start out as source code. Well, it's probably not terribly interesting to sign the source code itself. Signing the bytecode is very interesting. Interpreters are now seen as being insecure, and so we kind of cross that one off. But the verifier is what operates on bytecode, and saying if we can have bytecode be signed, there's a bunch of things you can do there. There's also cases for saying signed position-independent code, meaning maybe after JIT compilation, before prelocation. So for example, on Windows, classic drivers are written in that format, and the same on other operating systems. So bytecode and position-independent code are both interesting cases for signing under different scenarios. In theory, you could also say, I want to sign the native code after relocation, but that's not really very interesting because relocation replaces things with machine-specific addresses. Such a signature would only be useful for that particular machine or any particular point in time. A different style of approach, though, is to not sign the eBPF program per se, but rather to sign the thing that generates the program, if the program is either hard-coded into a user mode application or perhaps generated from a user mode application. Say, well, I'm just going to sign the application, and then any programs that one runs might be authorized. Okay, so again, this is a survey of different approaches that are out there. To take this question one step farther, well, does the signature over code, does that cover anything other than the eBPF program, or is it just the eBPF program? So again, when we look around different approaches being implemented or discussed, one approach is to say, well, I have a signature that only covers the eBPF program, regardless of whether that's in bytecode or position-independent code, see previous slide. Another approach is to say, well, it actually covers more than just the eBPF program. Okay, so approaches that say, Leaf, Bumblebee use, it may cover things that are more than just the bytecode or position-independent code. So, for example, Leaf uses packages where that package could be a user land application plus any eBPF programs that it uses. Okay, and you can push that out onto an existing machine. In contrast, a solution like Bumblebee packages things as containers, right? And then pushes out the containers with something like Kubernetes. This approach lets you distribute them through a regular app store, but it means you may be covering things as well, and you're not actually checking things at the time the eBPF program gets loaded per se, or at least you're not checking the signature just over the eBPF program. So if you consider an approach that passes the signature along with the eBPF program, it doesn't quite match in that type of solution. Then there's possible approaches that sign, say, a repository that contain multiple eBPF programs, whether that repository is, say, a file system, a directory, or some remote repository, some other type, where here the authorization would just check, does the program come from such a repository? And then finally, just like the last slide, at the bottom, you have a way of just signing, well, I'm not going to sign the program at all. I'm just going to sign, say, the application that generated it or the application that loads it, and say, as long as that application is consigned, it can do anything. This is a type of approach that's usually advocated when talking about tools like BPF Trace that do dynamic code generation. However, the notion of signing the source of the program requires either an interpreter, which, as we've said, is no longer seen as being secure, so we don't want that, okay? Or the ability to have dynamic code pages, meaning it does not work with things like hypervisor enforced code integrity. So what you'll find is that there's no like one size fits all possible scenarios today, okay? And so given that, well, how many different solutions do we need, right, when we have heterogeneous scenarios and requirements? Well, I'm going to argue the answer is still one asterisk, meaning I'm going to push the problem around. We'll come back to that. This is where this concept of a gatekeeper comes in, originally proposed by John Fastebend. Here, the point is that what's essential is the flexibility, not just hard coding whatever the answers are to the previous slides, right? Leaving that up to, say, the admin of the scenario to say what the answer needs to be in that scenario. So we talked about the example of, do you have HVCI or do you have BPF trace? If you can't have both, which one wins, okay? Another example, right, is if you need across different customers or different scenarios or different organizations or admins, you say, I want to have a policy that varies by, well, is it position independent code or is it bytecode? And what does the signature cover? Is it just the bytecode? Does it cover that in an application? There's heterogeneity there. Third example would be, what does the distro or OS use by default, maybe unrelated to eBPF? So, for example, the typical Windows policy is that only Microsoft signed code can be loaded in the kernel. And that's because if you call out Microsoft support, they're going to support it if it's actually signed by Microsoft, right? Whereas often people will use Linux specifically because they don't want the distro to control what programs can run, that the admin is in control. And so if you want eBPF to apply to both these categories of policies of code execution, then what do you do? Third or fourth example is if you want custom policies based on things like which key does it have to be signed by, and is it actually possible to run an interpreter or not? Please no. Whether it varies by user ID, location, or something else. So that's where this gatekeeper comes in that says, rather than hard coding the answer or the constraints into the eBPF framework, instead, we're going to put those into an eBPF program that can override whatever the default is. Okay? The program can then run on the device such that the policy can then meet the availability and latency requirements for being able to load eBPF programs. So let's dive into this in one deeper level, again, trying to keep our analysis across multiple platforms here. So if you don't have an eBPF gatekeeper program, okay, then it means you've got to have some hard-coded default. In other words, who authorizes the gatekeeper program, right? So the distro or the OS, the eBPF platform, regardless of whether it's in an offload card or an operating system or what have you, then it's got to have some hard-coded default. So let's say somebody picked a very strict default that says, I'm only going to permit eBPF programs signed by the distro vendor, okay? Which, as I mentioned, Microsoft had that as the classic policy for Windows drivers, right? Well, you can still use the gatekeeper, right? The gatekeeper can then be loaded anytime after startup to loosen the policy. It just means the gatekeeper has to be signed by the distro vendor, okay? Now, of course, some people will not like that and will not like the strict default. And the point of this presentation is to not take a position on which policies are good or bad, but rather to say that the gatekeeper can still be used in both cases, okay? The other case is, say, the loose default, which is to say to permit any program permitted by an admin or submitted by an admin. Here, as long as the gatekeeper is loaded before anything that's intended to deny, it's still fine, right? If it's loaded after that, then of course you can't prevent something that was already done, right? So in Linux, this just means it's loaded as part of the boot process. The gatekeeper has to be loaded as part of the boot process. Whereas on Windows, where eBPF is a separate driver, it means that you have to be loaded as part of starting the eBPF driver, right? In all these different cases here, you can still use the gatekeeper, right? The analysis is the notion of the flexibility and programmability itself is what is good. So just to sum up before I open up for questions here, the notion of signing programs increases security over just proving safety. The gatekeeper can apply across multiple OSs and distros, right? Multiple Linux distros, Windows and Linux, multiple Windows SKUs, not just those, anything else, okay? They can accommodate multiple types of signing and distribution mechanisms, which allows the problem of the tussles and the heterogeneity to be put on the burden of those who author the gatekeepers rather than on the core eBPF runtimes. And so with that, I will open it up for questions at this point. Thank you.
I wish you all could see the grief they're giving me behind the scenes. That was a great talk, and I sincerely appreciate the breakdown on classic code auth methods and not being a gatekeeper about gatekeeping. But also, everyone, if you want to learn more about those out of scope things that Dave talked about at the beginning of the talk, ask the questions in Slack. Now, that's it for our eBPF in the real world segment. So make sure you're back at 10:55. So that's roughly 10 minutes. So you can hang with Duffy as he gets us started with eBPF for networking. See you in a little bit.
Welcome back from the break. I hope you had an opportunity to stretch your legs, get some refreshment. And now we are going to enter a new section. This is going to be eBPF for networking section. But before we jump into it, I'd like to give a shout out to our friends in Zurich. So just downstairs from me in the office, we have, hold on one second. And I can't seem to play that. Can one of you do something about that? Thank you very much. So these are the wonderful folks that we have just downstairs at the watch party in Zurich, and the Zurich party is hosted by ourselves, Isovalent. It's also hosted by Puzzle and Vision. So great to see so many awesome faces learning so much in all of this. Our first talk in the networking section is going to be from Nick Tem, and he is going to, and the title of his talk is When You Need to Overcome Your Fear and Build Your Own Data-Driven eBPF Firewall.
Hi, welcome to When You Need to Overcome Your Fear and Build Your Own Data-Driven eBPF Firewall. This session is on our journey as a startup for using eBPF. I am Nick Temme, and I'm one of the co-founders of BubbleCloud, a pre-launch startup with a mission to restart privacy-safe innovation on your personal data. I have a background as a data engineer, and before starting BubbleCloud, worked as a data engineer for various organizations. Currently part of a small team that's trying to make BubbleCloud a reality. I have no previous experience before this project with eBPF or even programming in C, except perhaps using an Arduino for do-it-yourself home automation, but I'm not sure that that counts. Our journey of using eBPF starts with why we needed it. And the main reason is that we use a lot of virtual machines, up to 10,000 virtual machines per server. And that high density allows us to send services to these virtual machines that already have the encrypted personal data available. Well, this presentation is not on those virtual machines themselves, but it's about bringing data to the virtual machines, especially the firewall, to protect them. Important to note is that these VMs work in sets of 3, that allows us to be high available and consistent at the same time. So for bringing data to these VMs, we use Envoy. And we use Envoy as a SND-forward proxy, simply meaning we look at the requested URL and then forward the traffic to one of the underlying VMs. This works very well. The only downside is that it creates a large amount of individual routes. For every set of 3 VMs, you need 4 routes, 1 for each individual VM, and 1 that load balances over the set of 3. For example, if you have 250,000 users, that would result in 1 million individual routes. And that actually works. The only thing that we found that would not work are health checks. And if you have 1 million individual routes, using health checks would create more CPU usage, memory usage, and bandwidth than what we actually need for the virtual machines themselves. And that was not really an option. We did, however, want to use a failover system that if one of the VMs, or actually the node where the virtual machine was running on, Envoy would simply fail over to the next virtual machine of the same set. To make this happen, we actually found a system that uses IPv6 and give every virtual machine an individual IP address, and that allows us to do exactly what we need. If one of the VMs go down, Envoy simply goes to the next VM. It just retries without the need of individual health checks. Well, we do, however, want to have a firewall on the node level because the micro VMs are simply not powerful enough to protect themselves, and we wanted the additional security having a firewall on the node level. Now, if you look at that from a traditional firewall perspective, the rules you need are actually quite simple. Looking at a set of 3 virtual machines, looking at data center, or actually the server, data center A, You would need a firewall rule that allowed traffic from VM2 to virtual machine 1, and another one to allow traffic from virtual machine 3 to virtual machine 1 on the node of data center A. And you would have to repeat these rules for each of the virtual machines on that same server, each of the 10,000. That would result in over 20,000 firewall rules per server, which a traditional firewall, like for example IP tables, simply cannot handle. So we went looking for a solution. The requirements are actually quite clear. We need to support IPv6. Our whole routing and failover system is based on that. And we needed to have a map or lookup-based solution. So instead of parsing through all the individual rules, ideally one lookup would be enough to decide, is this traffic allowed or not? Also important is that it looks at the hardware network interface level. The whole goal is to have a firewall on the node that looks at the traffic for all the virtual machines running on that. Our requirement was that it would filter on the source IP, destination IP, in our case also on the destination MAC address, to prevent IP spoofing. And we looked at various alternatives: IB tables, IPsec, EB tables, NF tables. And for us, it didn't really work. It was either difficult to implement, or we needed to chain these solutions into a solution that we thought was quite hacky. So we refocused on eBPF, or specifically Express Data Path, that allows you to attach an eBPF program to a network interface. Now, to be honest, one of the reasons we looked at this technology is that it's a cool new technology. That might not be the best reason, but in all honesty, that's the reason why it came on our radar. And it seemed to be built exactly for a use case. Fast in theory, and also it allowed for map lookups, which was exactly what we needed. So what was the downside? The only downside for us, at least from a conceptual level, is that you had to write eBPF in C. And we had no experience with that. As I said, the only experience I had was working with an Arduino and how difficult it was to use strings compared to other programming languages I was familiar with, for example, Python. I'm stopping here the complaining about C. I actually got quite fond of using C, but for us, this was actually a real barrier to get started. So how did we, what did we do? How did we get over this fear of using eBPF? Well, the first, of course, is to look at existing examples that are out there. And our use case seemed to match exactly a typical use case. I think the only thing is you have to look for a recent example, but there are many examples out there of an example firewall to do a lookup for source IP and destination. What made it easy for us is that we are actually specifically only looking for the TCP traffic of IPv6, and basically would narrow it down to that area of network. The second thing we did is to check if eBPF actually works at the hardware network interface level, because the basic question is, do we see all traffic of all the VMs that are running on the node? And yes, it does. I think debugging it was a little difficult, or making sure that it was true. This would be actually my only complaint about eBPF, is how to debug it. I'm sure maybe there are better ways, but we use a lot of tracing to actually see the traffic that was coming in. If you can see the traffic coming in, it means you can build a rule around that to either block or allow the traffic. And of course, what we wanted to see is, can we build a map that allows us to do everything we want, ideally in one lookup? Also, that was possible. In reality, BPF supports many types of tables. I think the hash table is the most used table in these examples of firewalls. Actually, I don't think I can think of an example that uses a different type of table, and that allowed us to do everything we needed. Last check, of course, is, does it scale and perform? And of course, that was an answer. The answer to that question was yes. It could easily allow over 20,000 entries in the map. I can share any network graphs. The only thing we checked is there a significant, do we see significant degradation in network performance if we enable this firewall? And the answer was no. So yay to all the problems we had on our data plane perspective. So let's look at this solution in a little more detail. I think this is a typical diagram of what you would see to explain Express Data Path. You have an eBPF program attached to a network interface, and that program checks each incoming packet and then either allows or drops the traffic. And one of the things it can do is do a map lookup, and based on that lookup, decide to either allow or drop the traffic. You would typically see a utility in Linux user space that allows you to add entries or remove entries to these maps. And that's exactly what we did. So we would read the source IP, destination IP, and the destination MAC address from this incoming packet, do a key lookup in the map, and then either drop or allow the traffic. In reality, an eBPF map is consistent of a key value. So it only allows you to do a single key lookup for every lookup you do. Luckily, it's possible to make a composite key that allows you to look up sub-values. Or better said, it allows you to combine these values into a single key. And that's what we did. So we created actually a step 1B is to look up the source IP, destination IP, and MAC address, and then create a composite key of these values so you can do a single lookup to see if that exists in the map or not. This is how it's solved. Every key is basically a C struct, and that C struct can consist of different underlying values. Here you see that actually the source IP and destination IP and MAC address are actually split up in different underlying values that make up of this composite key. The only thing we basically had to add to all the examples was here, the last part you see at the bottom, is to look at the destination MAC address. The only trouble we had was that because now we use different length of values, you have to pad the key. You see there at the bottom, actually the BPF documentation from Cilium explains this rather well, why and how you have to do it. So, data is being protected. One step left. Of course, we didn't want to add 20,000 entries manually. So we needed something that automatically enters or removes the map entries. So we built our own control plane. That might sound more complicated than what we actually did. So we based our control plane off 2 self-healing loops. And that goes basically back to my background as a data engineer. And I think how everyone solves complex problem, you try to redefine it into a problem area, and for me, that was redefining it into a data problem. So we separated the data problem, which we could use Go for to develop that. And then we created a small C command line utility that was actually responsible for adding and removing the map entries. Now, we were aware that there were several libraries available that allows Go to directly interact with these eBPF maps. They looked rather complex to us to use. Maybe that's just us. And also, we're not sure how we would map the Go data structures to the C struct that was key for our key value lookup in the eBPF map. So what we did was write a simple C command line utility using readily available examples that are out there. And that C command line utility has 2 main functions. One is a command line that allows you to add or remove entries in the eBPF map. That takes a source IP, destination IP, and a destination MAC address as input, and also whether to insert or delete it. And the last input is that it needs the interface to actually connect to the right map. That could be different for each of our servers, so that's why we made it a separate argument. The second argument actually loops through the map and then exports all the entries into a CSV file. This allows a Go program to read that CSV file and then actually make sure that the entries are all correct. That's running on the node itself. Actually, that Go program receives the central instructions from a central control server that decides what firewall rules need to be there exactly on each server. But this uses CSV. Here you perhaps see my real background as a data engineer that always falls back to CSV somehow. I'm not sure that's for everyone. The big advantage of using CSV files is that they're easily readable, and it's also very easy to make an iterator over those values. Using two self-healing loops basically is the basis of this control plane, where simple central server decides what rules need to be on each server. The server detects the desired state and then makes sure the Go program executes the command line utility to either add or remove the entries in the BPF map. Again, separating the data logic from the logic to add the entries into the BPF map using a simple command line utility. That was the easy solution for us. So what do we learn? XDP plus eBPF maps are great. And they're fast, and it's very easy to tailor them to your own solutions. You have many ready-to-use examples out there that you can easily get started, and tailoring that to your specific needs is actually not that hard. Easy to integrate with other technologies through intermediates. We use the command line utility and a CSV file. Again, perhaps not for everyone, but for us, it worked great. Which means we're no longer afraid of using eBPF. Perhaps it's time for questions right now. You can also just contact me at nick@bubble.cloud. Of course, we want to give back to the community, so we're trying to upload everything to GitHub. Maybe we don't have enough time to clean everything up, so what you might see right now is still a work in progress, but that is clearly stated. Thank you for your time.
Hey everyone, thank you very much for that wonderful presentation. There was actually a lot there. I mean, and there's a lot that overlaps with some of the visibility that we built into Cilium itself. In a recent Echo office hours, which happens every Friday, either in Pacific or UK time, we actually did a session on a thing called the Cilium recorder, and the recorder was tooling that allowed us to do specific packet traces on things that move through the XDP data path to allow for better visibility of that traffic. So, I mean, it's really neat to see. Really neat to see that work, and it's kind of a validation of some of the things that we've been building into the product. So, pretty neat stuff. Our next talk is troubleshooting and healing networks with eBPF from our very own Martinus Pumpitus here at Isovalent.
Hello BPF people, my name is Martinas. I'm a software engineer at Isovalent working on Cilium's data path, and in today's talk I would like to show you some superpowers of eBPF in tracing and networking. For this purpose I'll be using BPF-based Linux Kernel network packet tracer to show some advanced optimizations in Cilium's data path. Alright, let's introduce the tracer. At Isovalent, we built a Linux kernel networking packet tracer called Packet Where Are You, or pronounced Peru. The tracer extracts the BPF metadata from the kernel, and then it uses that to figure out which functions in the kernel are responsible for packet processing. Afterwards, it attaches BPF programs to those functions to do the filtering via kprobe interface. The tracer can be used not only for debugging networking issues in production, but also for development purpose. With this background information in mind, let's move to the networking part. A typical way in Linux to connect containers is to use L2 software bridge and virtual Ethernet peers, as you can see in the diagram on the slides. With Peru, we can observe a packet path in the Linux kernel when it's being sent from outside to the container. First, after the NIC passes the packet to the kernel stack, the net filter handling is happening. Afterwards, the fib lookup to determine the next hop, then the net filter handling again, then the packet is finally forwarded to the bridge net dev. The bridge netdev is doing net filter handling again, then fib lookup, then L2 neighbor resolution, then the packet is being cloned, and finally it's being forwarded to the attached virtual Ethernet device. The virtual Ethernet device in the host network namespace transmits the packet by pushing it into the CPU backlog queue. And finally, it's being received by the virtual Ethernet device peer in the containers network namespace, and it's being handled by the TCP IP stack. Let's take a look what happens with the exact path in Cilium's BPF-based data path. For this, I'll be using the BPF host routing mode, which is heavily relying on the BPF redirect peer helper, which was introduced by my colleague Daniel. So let's run Peru and let's send the packet. As you can see, the packet is first handled by the BPF program, Cilium's BPF program, which is running on the TC ingress of the public-facing device. And the program is using that helper to push the packet directly into the container's networking namespace. So we can bypass a lot of functions, and it's not only giving us performance benefits, but also drastically simplifies packet path. Finally, we can visually compare the both call stacks. On the left side, you can see the traditional container networking stack, and on the right side, Cilium's call stack. That was it. Thank you for your attention, and happy to answer questions on Slack.
Thank you, Martinez. That was great. And I have to say, I'm always on the lookout for like the next, like really interesting way to make a presentation. And I absolutely love the thing of like presenting it with beautiful mountains in the background and like having a screen. That was like one of the better layouts. I really liked the way that worked. If you have questions for Martinez, definitely check out the Slack. He's in there all the time, but he's in there especially right now to answer your questions. So put those questions into the thread, and I'm sure he will be very attentive to them. Our next talk is eBPF for I/O latency monitoring by Jan Glover.
My name is Jan Glauber. I'm working at DigitalOcean in the kernel and performance team, and I would like to briefly talk about what we are doing for I/O latency monitoring. So we are a cloud provider. We do have a fleet of servers with lots of VMs running QEMU and KVM, and we need to continuously monitor performance data for internal and external use. We do get a lot of metrics per virtual machine for CPU, memory, I/O network, and much more. And we use Prometheus and Grafana to store and retrieve the data. One area where we wanted to improve ourselves was measuring of local storage. We only had per disk latency per machine, so we didn't have any per VM data. We didn't have data for read-write operations, and also latency is influenced by many factors, for instance by block size or by number of I/O operations. So basically we wanted to monitor and track every single I/O request. That's where BPF came into play. It was already used heavily for tracing, so I thought it would be a good match. Now we had a number of questions at the beginning. One thing is we have a complex disk setup with RAID, DM, LVM. So which layer should we trace on? Should we trace requests or block IOs? Luckily, there are trace points already in the I/O path. So should we use trace points or raw trace points, or rather stick to K-probes? Also, for user space tooling, we are bound to Golang because of our middleware stack. So we needed to decide which library to use there. And also, what's the performance overhead of BPF? What would it mean? We already knew that we couldn't monitor every single I/O event, but had to kind of aggregate inside the kernel. So I played around with different options we had and finally decided on using raw trace points on block I/O layer. That was good for us because tracing the block I/O struct, we can do a lot of filtering. So I filter out every disk I'm not interested in. We can filter out processes we are not interested in. So this is a short snippet of the trace points we are using. The actual code is quite longer. And with this in place, it was quite easy to implement the whole thing. So at the bottom, we have the VMs. And as we have the I/O path instrumented, whenever a VM does I/O, we atomically increase the counters we are interested in. The counters you can see in the BPF maps part for read and write operations, for bandwidth and IOPS and other things. And we're the simple hash map indexed by the process PID. And then on the left side, we do have a user space component that tracks all the active VMs. From time to time, it gathers the data from the BPF hash tables. And it also has to do householding because VMs come and go. So from time to time, we need to remove inactive VMs to not fully utilize the BPF maps. And then we can create histograms or P90 or whatever from the data we have and export it on a local port so it can be retrieved. So to summarize, as I already said, we do tracing on block I/O layer. We use raw trace points. We decided to use Cilium eBPF, which worked greatly. We measured that the performance overhead is quite low using BPF stats. We do have a possibility for custom filters, and it's easy to extend the BPF code. And it's also faster than parsing procfs. So what's open? Every project's got a to-do list, and the biggest pain point for us is kernel versioning support currently. We had to ship multiple BPF programs matching the kernel versions we are using. So that's something we need to work on. Another thing is we had to extend BPF code to have kind of versioning between our user space component and BPF because the data structures can differ. We need to make sure it works even after an upgrade. And there's more to do, like dynamic map sizing, which we didn't yet look into. So thanks for your attention. I would love to hear your feedback or comments.
Awesome. Thank you very much, John. That was great. I really like that. I liked the idea of basically putting this into a way that where you can filter out those events that you're actually interested in seeing, so you don't have a ton of noise, and also the careful way in which you're actually managing the amount of data that you're putting into that map that you flushed onto user space for eventing data. That's really cool stuff. Next up, we have Zheng Wang, who is going to talk about improving Cilium's eBPF-based DSR performance by adding support for IP and IP.
Hello everyone, my name is Jiang. Today I will present improving Cilium's eBPF-based DSR performance by adding support for IP in IP. I'm from ByteDance. Cilium is open source software. It provides secure and observe network connectivities between container workloads. And by done, we deploy Cilium on a few edge network sites. We use it as a Kubernetes CNI to provide networking and replace the kube routers because Cilium has less CPU usage. In Cilium, there are two networking modes. One is the SNAT, SourceNet mode. For the SourceNet mode, the client sends the request to the VIP, and it goes to the load balancer. The load balancer will replace the source IP with the load balancer IP and the destination IP as the pod IP and reach the pod. In the pod reply, it also goes to the load balancer. The load balancer transmits the source IP to the VIP again. So that means every request will go to the load balancer. If there are lots of nodes here, the load balancer may become a bottleneck. Another mode is DSR mode, or direct server return mode. In the DSR mode, the client sends the IP to the VIP as before, but load balancer does not change the source IP this time. It will just forward the packet to the pod IP, to the pods with the pod IP. In the pod reply, they can use the client IP as the destination IP and send the reply directly to the client. So this benefit that there's less processing on the load balancer, but the question is that where do we store the VIP? On the current Cilium, the implementation is that the VIP is stored in the IP options. The upper is the original IP packet with the last protocol checksum and source IP and destination IP at the VIP. To forward the packet, we have to change the destination IP to the pod IP. Then the Cilium saves the original destination IP and pod into the IP options. And this one will works. But there's one issue is that the performance will be slow on some network switches. On network switch, there are also fast path and slow path. For the IP packet with options, will go to the slow path on many switches. And that means the switch has to examine the IP option and see if it has anything to do with the switch or go to the control plane or not. So that means when the network traffic is even not very high, the CPU usage on the switch will arrive 100% and become the bottleneck. So the question is, can we do better? So for that, we propose the IP for DSR for IPv4. So basically, we use IP. That means we have two IP headers. The upper is original IP packet with the source IP and the destination IP as the VIP. Then we add another IP header as the outer IP header. The source IP is the load balancer IP, and the destination IP is the pod IP. And there's no IP options this time. And for the inner IP header, we again change the VIP to the pod IP for the easy processing. And then we save the original destination IP and the destination pod into IP options. But I think this IP option is inside the inner IP header, and the switch will not check the inner header. It will just check the outer header of the IP header, outer IP header, and then it will go to the slow path on the switches and have the better performance. The only drawback is that the MTU has to be smaller because we add another IP header is about 20 bytes for the UDPs. For the TCP, because we only do this for TCP SIM packets, so that means only the TCP SIM packet has a smaller CPU. For all the other packets, the TCP packet is still the same size. And that's all. Thank you very much.
Awesome. That was a great talk. Thank you so much. That was a really good one. It's IP and IP is actually a really interesting overlay technology or encapsulation protocol for moving traffic back and forth between servers. And Zhang is a great contributor. We've actually seen a number of great contributions from him. The next person we have is Tok, who's going to talk about the promise of eBPF for the edge. Welcome, Tok.
Hello everyone, my name is Toki Harland Jørgensen and I'm a kernel engineer at Red Hat working primarily on the networking aspects of BPF. And I am here today to talk to you about the promise of eBPF for the edge. So, why am I here and why is Red Hat at the BPF Summit? We are here because Red Hat loves BPF. We invest quite heavily in it in various ways. First of all, we have full support for eBPF on Red Hat Enterprise Linux. We do full kernel backports of all features from newer kernel versions on each minor version of RHEL. So for RHEL 8.7, we are up to upstream kernel 5.14, and for RHEL 9.1, we are up to 5.16. We support kernel features in eBPF, and we offer support for BCC tools and BPF trace. And there's a link to the full documentation and the release notes there. We also have several people working on development of eBPF, myself included, for kernel contributions and in networking, tracing, HID, and others. We also maintain and contribute to various user space libraries, libxdp, IAA for Rust, and we maintain code examples and documentation like the XDP tutorial and the BPF examples repository. All of these are links, by the way, so you can click them if you download the slides afterwards. And finally, we are a platinum member of the eBPF Foundation. So, with all this, and particular with respect to the Enterprise Linux kernel, I would also like to implore everyone to not use the kernel version for detecting eBPF features when you write your BPF programs. Because even though we do full backports of kernel features to RHEL, we don't actually update the kernel version as it is expressed to user space, so you really need to use feature probing to see what is supported. The BPF tool feature output will show you all of this, but you can do similar things in your own application. Now, with all that out of the way, let's talk about the edge. So, what is the edge? It's this thing where operators and application developers discovered the speed of light, which obviously sets us a fundamental limit to how quickly you can respond to applications. If you have your application in a data center in the cloud far away from the user, you do need to incur at least one round trip for every response. And as applications become ever more interactive and latency becomes ever more important, this actually becomes a real limit. So you can do various things to mitigate this, and one of those is moving things closer to the application, so into the edge. And in this respect, the edge here includes, as you can see in this diagram at the bottom, all the various devices close to the user, so mobile devices, Internet of Things, smart things, but also things like CPE devices, the home routers you have in your home. And it also includes the edge infrastructure, i.e. servers that sit near the edge of the operator networks. So it's sort of similar to a data center, but it's smaller scale, and there's a lot of it distributed around. And obviously, as you move up this diagram, the faster to slower is in terms of response time. So the closer you are to the application, the closer you can respond to user input. And this is, of course, a restructuring where everything used to be really centralized in the cloud. Now things are getting distributed out closer and closer to the edge. And this brings with it lots of challenges. So, what can BPF do for this? Well, in general, BPF works in these different areas: networking, security, and observability. And if you have the intersection of networking and security, you get network security. And the intersection of networking and observability, you get network observability. And security and observability gets you real-time threat detection and response. And if you combine all of them, you can get intelligent sandboxing. So all of these are areas where BPF can be used today, and as we are starting to see applications use them, as you probably know. So moving this to an edge context, what does this mean? Well, for networking, one very important aspect of BPF for networking in an edge context is just simply lowering the overhead, because applications are now running on smaller devices. Some of them are still servers, but they're still smaller servers than what you would see in a data center. And you don't have a whole cluster. You will usually see things like container deployment be on a single node instead of a big cluster. You will also see network function virtualization, NFV, being deployed near the edge. And in general, the applications or the CPUs moving network traffic are smaller and have trouble keeping up. So in particular, XDP acceleration is a type of software offloading where we can keep up with ever higher data rates, even though the CPUs are smaller. So with HTTP, you can do things like accelerate your firewall, or your load balancing, or even your packet forwarding, say in a CP on every device, and scale these applications out instead of having big centralized boxes that are expensive and that you can't deploy everywhere at the edge. For monitoring, because applications are distributed out to very small machines, you will need performance monitoring to scale with it and go with it through all the nodes in the network. And here, low overhead performance monitoring is important, which is obviously one of BPF's strengths. Also, it allows you to have always on application monitoring, so you can have usage reporting even though your application scales out over multiple nodes at the end. Finally, for security, things like firewalling and DDoS protection you can no longer do in one place at the perimeter of your data center, now that the application is distributed throughout the edge. You will need to integrate this on every node. And here again, as I mentioned above, accelerating things, for example, with XDP is a way to achieve this. Also application isolation, because you can't provision a physical machine for every application. You really need application isolation to work reliably on a single node, which is also where we see BPF potentially being able to help. And finally, custom security and monitoring and enforcement is an area where you can build in all these capabilities in your application by including a bit of BPF code and getting real-time metrics out of it. Now, all these are areas where BPF can help on the edge, but as BPF gains more ground in these things, there's one issue we really need to solve, and that is eBPF hook coexistence. So as more applications start having more users, coexistence of the different BPF programs becomes important. This means, in particular for the networking hooks, but really every hook you must assume that other programs will access your hooks at some point. Not every hook in the kernel support this natively. In particular, the XDP hook only allows you to load a single XDP program. We've developed libxdp as a way to allow multiple XDP programs to chain on a single hook. And because we see this as a hard requirement going forward, it's actually mandatory to get support on RHEL that you use libxdp for your XDP programs. However, this is not a completely solved problem. More work is definitely needed. We need to define a security model for how different applications can coexist on the same hooks. And we also need better tools for admins to override this. This goes back to the assumption, right? You may think that you can assume that you own the hook and that you will just bail out if another program loads. But as Daniel Borgman was showing us at this year's Linux Plumbers Conference, there's a link to the talk there, this can actually fail because users and administrators may want to run multiple programs and they may step on each other in various ways. So really we need to have some sort of cooperative coexistent hook on most of the BPF hooks. So bear this in mind when you're developing applications. So with this, we think that BPF has a lot of potential for the edge. So how are you going to leverage eBPF in your edge solution?
Thank you, Toke. That was great. I really enjoyed that talk, especially the relationship with the edge, and also, I mean, really bringing up some very important points about, you know, if you have multiple things that are instrumenting the same hook point, what happens in the collision case, right? Like if we're all instrumenting the TC hook, what happens? Like, how does that actually work out? And is there better orchestration that's needed for that sort of stuff? So it was a good call out to Daniel Borgman, and also a really great point related to his talk. So we are going to our next break. This is going to be a quick break. It looks like it'll probably be about 5 minutes. We're going to come back at 11:45, and we're going to jump right into Liz and the first part of our CTF. The rolling slides during the break will actually have the pin, but when we rejoin with Liz will actually show you how to get logged into Kahoot. When you create your account in Kahoot, try and use the same name as you do in Slack, so that when you do amazingly well, we'll be able to congratulate you.
pretty late for them at this point, so they're probably partying into the night over there. So thank you very much for joining us. Also joining us today to help with the Capture the Flag is my colleague Natalia. So welcome to
Branko. I work as a security architect at Isovalent, and I'm really happy to be here.
Brilliant. So the Capture the Flag this year comes in 3 parts, and we want to make this interesting for everyone. There is something for everyone. So part 1 of Capture the Flag this year is a quiz. Hopefully you've all already found Kahoot. You can use the website at kahoot.it, or you can use the app if you want to do it on your phone. You can see the game pin there in front of you. It's 393347. Please use your Slack handle, because people who do really well in this quiz, we're going to send you a swag voucher through Slack. So that's your incentive to take part in this quiz. So let's bring Kahoot on. I'm just going to give a couple more minutes to see if more people want to join in while we're doing that. Natalia, you're dialing in from Hungary, right?
Yeah, I'm joining from Hungary. It was actually a pretty sunny day today, so we had really nice weather.
Lucky you. I am in Zurich. We have been hosting a watch party here in Zurich as well, in the Isovalent offices, and it has been pouring with rain since we've been here all week. I can see a few people are still joining, so I'm going to stay on this screen for a little while a few more people join. Hopefully you are using the same name that you were using in Slack, don't forget. We'll give this just a few more seconds, so if you do want to join in with the quiz, now is the time to do so. I don't know if people can join in once it starts. Oh, somebody's joined in with the pin. That's not what the name, that's the pin.
Yeah.
Okay, a few more folks joining in. I can see a couple of names there that I recognize as regular viewers of the Echo eBPF and Cilium office hours show that we do on Fridays. So shout out to those of you who join us on Fridays for those YouTube sessions. We're actually going to be using this week's Echo for the 3rd part of this year's CTF challenge. So I will talk about that later on. There's still a few people joining. I can still see that number ticking up. So going to give it a few more seconds. And if you, every time I think I'm going to say, yeah, okay, let's start, a whole load more people join in, which is awesome. Keep joining, people. This is great. Thank you for joining. And if we fall a couple of minutes behind schedule, so be it. That's how we're going to roll today. Okay. Oh, the number went down there.
Yeah, it's really great.
Left and joined again.
I can also realize people from last year, so I'm very happy that you guys joined.
It's always great to see some familiar names. Okay, the people are still joining, so I'm going to keep waiting until that number settles down. Michi the gamer. Oh, this could go on all night. We didn't allow for time for people to join the quiz, but this is good. I'm glad you're all joining. I know sometimes these things can take a little while to load up, so those numbers are still going up, so we will stick with it. While we're doing this, Natalia, why don't you tell us a little bit about what your day job is at Isovalent?
Yeah, it's very interesting and a lot colorful. I work with customers, I work with clients, I work with like engineers. Very interesting, and a lot of things are going on. A lot of like very smart people. Yeah, I work on mostly like security related stuff. How would our customers use like our product in their environment? How we develop like different kind of features. Yeah.
We're going to hear like your whole life story by the time people have finished signing in at this rate, I think. I'm going to give it I'm going to give it 30 more seconds, and I think we're just going to start. So I hope you're all joining quickly. So I see a few more familiar faces. I see some of our speakers. I can see Dave Thaler there. Nice to have you with us.
I actually realized some teammates from here, so.
Brilliant. All right, so we have hit the end of that 30-second deadline, so I'm going to hit the start button, and I hope everyone who wants to join has made it. If you didn't manage to join in, you can still play along, guess the answers, or know the answers yourself. All right, here we go. First question.
All right, so who conceived the original BPF technology?
So I think there's a few familiar names on those answers. There's a couple of names there that I don't actually recognize as well. So you need to get your answers in quickly, people. You've got 3 seconds. I should probably say the faster you answer correctly, the more points you'll get. So those of you who answered Van Jacobson and Stephen McCann, you are correct. They were the authors of the original BPF paper. So, somehow we seem to have 0 scores. I hope that's going to change. All right, next question.
Where was this picture taken? So it looks like a really sunny place. I wouldn't say it's Oxford, but maybe Oxford.
Based on how it's been raining this week, Zurich doesn't look anything like that to me this week anyway.
Looks like a laboratory.
All right, so if you said Berkeley, you were correct. I think we got a few people who should have had some points. Yes, we've got some points. Gavin B topping the leaderboard. Right.
So what is an elf? It sounds like a Lord of the Rings character.
Definitely is a Lord of the Rings character. But that might not be the answer we're looking for.
Maybe a hobbit. But that might be something related to the technology.
Great. So if you hit the blue button, you were correct. ELF stands for executable and linkable format. Is that right?
Yeah, it's right. It's correct. It's an object file that an eBPF program is compiled into.
All right. So Bora is the highest climber.
One important point. I need to interrupt you for just a moment.
Okay.
What's happening is the timeout is very quick, and so people see it, and then there's the buffer, and then they're trying to interact.
Oh, wow. Okay. So
If
Duffy
there's a
has
way
come
for you
in
to increase the timeout.
to see if, I wonder if I can do that. I might have to restart the whole quiz to do that, I think. Okay. I'm not sure we can. You're just going to have to press buttons really fast. So don't take it too seriously. This is only part 1 of the CTF. That is a really great point. We didn't think about the buffering delay. A few people are able to get there really quickly. So actually, while Duffy came in, we had that question go through. These are the project logos. So if you didn't recognize them, the one on the right was a project called DeepFlow, which is a newly added project on the eBPF.io landscape. All right. Congratulations to Runa, who's climbing up the leaderboard. Okay.
Up to 7 places. Wow.
I wonder if there's anything I can do here to make it go slower. I can't see a way of doing it there. No, unfortunately not. All right. We're nearly halfway through.
So what happens if you are receiving packets while an eBPF program is being updated? So we might drop some packets, but it just works like magic. That would be amazing.
I hope packets are not being dropped.
Well.
Okay, so of course, it just works like magic. All right. Runar is still at the top of the leaderboard. Petty is the highest climber.
Is the highest climber?
We're halfway through.
Wow. So what use case is not yet covered by a major project on the eBPF landscape? So we might know something about networking.
Yeah, I think if you think about Cilium, some of those. And of course, orchestration is not yet covered, but networking, observability, and security are all implemented in eBPF by projects on the landscape. Okay, a little bit of...
All right, so we got 3 logos again. I kind of like the pink one on the left. It's very cute.
It is very cute. And the one in the middle is pretty new.
Yeah, I haven't seen it before.
All right, more people got that answer right this time. And yeah, so BPF Trace, Kepler, which is a really interesting project that's using eBPF to measure energy usage. So you can track how your software is using energy. And of course, Falco. Oh, we have a new leader. Hi, Woo. Great.
Wow. All right, so who are the maintainers of eBPF? Well, there is one answer that BPF maintains eBPF itself, which would be also amazing.
That clever. Yeah. And of course, 2 of our keynote speakers at eBPF Summit this year are maintainers of eBPF. So maybe we'll have Andre join us next year as well. Okay. No change at the top of the leaderboard by the looks of it.
So where was the most recent Linux Plumper conference held?
Some places that are less rainy than Zurich this week.
So that's definitely not Punta Cana.
Of course, it was Dublin. I think quite a few of the folks who've been speaking at the eBPF Summit today and tomorrow may well have been in Dublin for that conference. Oh, a new leader, Matt Ward, has taken the top spot. Okay.
So what is the name of the bee? That is really interesting because we gave name to the bee at the last year's summit. So who were here last year might know the answer this year.
Yeah, I hope everyone knows the answer to this one. Even if they have to press the button like a speed challenge. Of course.
Right. A lot of people know that.
Yeah, that is EB. All right, so let's see who has done well. So Runar Christophe, Blessure, and the winner is Matt Ward. So congratulations to the 3 of you. I also see a couple of runners up there, Michi and Warwick. So congratulations to all of you. Thank you, everyone who participated. Sorry, we completely didn't think about the delay on YouTube. So if you were unable to participate, I hope it was still kind of fun to watch and maybe you saw some fun questions there. All right. So that is the challenge 1 of the eBPF Summit CTF. It's complete. If you took part, if you tried to take part, if you even got as far as downloading Kahoot, I think you should grab this image, which is like a little prize to say, yeah, I completed the capture the flag. You will be looking for 2 more images like this to indicate when you've solved challenges 2 and 3. But I would say that bee looks like a kind of another bee and it seems to be holding 2 flags. So maybe you want to grab a screenshot of that B for another reason as well. That's a bit of a trick there, I think. Okay, hopefully you've had time to capture your flag. Get it? And let's talk about challenges 2 and 3. So if you want to get your hands onto a terminal and start working your way through challenges 2 and 3, you'll find both challenges and all the instructions you need and everything you need to get going in the site you'll find at isogo.to/CTF2022. That will take you to the repo that gives you the starting point for both challenges 2 and 3. When you solve those challenges, you'll find images with bees holding flags. So if you manage to capture those flags, post them into the eBPF Summit Slack, and we'll know that you have managed to achieve those challenges. But please don't put any spoilers into the eBPF Summit channel. We've got a special channel called eBPF Summit CTF Spoilers. Feel free to go in there, ask questions, ask each other for hints, help each other out. But save the eBPF Summit just for showing off when you finish those challenges. So with that, wishing you really good luck for solving those challenges. Come back tomorrow if you want to hear about how to solve challenge 2. And we'll be talking about how to solve challenge 3 in the Echo show on Friday. We'll send out all the links for that later on this week. Good luck. With that, I'm going to hand over to Duffy.
Yes, the CTFs are like some of my absolute favorite parts of pretty much any event like this. I absolutely love them. And they're just such a great way to interact and to learn and do other things. Speaking of learning, we're about to hear from one of the people I get to work with here at Isovalent that I have learned so much from, and I'm sure that this is probably true for quite a number of people in the eBPF and Linux communities. Mr. Dan Borkman is going to give us a keynote on eBPF innovations in cloud native. Welcome, Dan. And remember to ask your questions during the event so that we can ask those questions live when it's over. So make sure you ask your questions. And welcome, Dan. Thank you very much.
Hello, welcome to my talk about eBPF, Innovations in Cloud Native. What is actually cloud native? There's in fact a definition from the CNCF, which says that cloud native computing is an approach in software development that utilizes cloud computing to build and run scalable applications in modern dynamic environments, such as public, private, and hybrid clouds. The techniques for that are loosely coupled so that you have resilient systems that are more manageable and observable. And the whole goal is to make high impact changes frequently and without disruption. I usually don't look at analyst reports, but it was interesting to see that by 2025, Gartner estimates that over 95% of new workloads, they're in a cloud native environment. And Kubernetes is in fact the pillar of cloud architectures and also used for cross-cloud orchestration. The cloud native embraces the container model. The container model is, essentially the single kernel becomes the common denominator. It has to manage, opposed to having full-blown VMs as in the past, right? The scale and scope is also changing. So while in the past there were a few VMs, now there are many containers. The container density on a node is high to maximize the resource usage of a machine. The lifetime of a container becomes shorter. With that, also higher IP churn. In general, the trend is to move to generic worker nodes with co-located specialized functions, like your whole cluster becomes a load balancer as well. The challenges don't just stop there. So once you have your initial cluster up in Bootstrap, there are day 2 challenges that we call. It's mainly around integration with external workloads. For example, when you don't just move to a cloud native environment with a flick of a switch, but it's a successive step. And that also requires to interconnect with other existing workloads through more predictable IP addresses. Successive migration to IPv6 only clusters is a topic because Kubernetes supports it and it allows for more IPAM flexibility. With that comes also the need for Net4664 to interact with IPv4 based workloads. And once you have multiple clusters, now the question is how to connect them together in a scalable way. Topology-aware routing is a big issue around that, also traffic encryption between those clusters. And observability, especially scalable observability, in order to detect or troubleshoot issues in the cloud environment. Scalable network and runtime security enforcement is important, and of course, an improved networking throughput and latency. What about the building blocks? Well, the kernel, as usual, is the foundation. Given the applications, they use sockets as data source and sinks, and the kernel becomes the common denominator. The networking is the communication bus around that, and typically the Linux kernel and Kubernetes together is seen as the cloud OS. There are many building blocks. A lot of them have been designed more than 10 years ago, and they're often loosely coupled, which means those individual subsystems, they don't talk with each other. They're like some of them are inflexible, which only allow for global node policies, but not per container policies. Or some of them are inefficient simply because they have been designed back then, and back then it was good enough. But the typical example here is the list style processing that we see with IP tables. On the right side here, I posted an IP tables dump from kubeproxy when there are many services connected in the cluster. And also there's no pod awareness. So really, if developers want to provide tools for cloud native environment, they're stuck in this box, and a lot of those things, they cannot be expressed efficiently for modern environments. So how does eBPF come into play as a cloud native tool, and what innovations does it bring along with that? First of all, eBPF is a framework to extend US kernel. It's a general purpose engine with a minimal instruction set, and it allows for running programs in the kernel to customize its behavior without changing the source code. Those programs, they can be updated on the fly without node reboot, for example, or even workload disruption. They're verified for safety, so they don't crash the kernel or make it unstable. And those programs can also be made portable between different kernel versions. And what you can see then is you can shift context from user space, from Kubernetes into the kernel thanks to BPF. And I now want to talk about 10 innovations that I think that eBPF brought to the table along with its framework. So number one, BPF allows to significantly speed up the development. I think that's really important because if you think of a typical patch life cycle, you need to develop the patch, get it merged upstream, then you need to wait until major distributions get released with it, but it doesn't just stop there because also users, they have to adopt it. And typically what we see is users, they like to stick to LTS kernels, understandably, and they have like a 2-year release cadence, which is really long. So if there is, if in the old model innovation should happen and it's needed in the kernel, then that usually required to change the kernel itself or to build kernel modules, and that leaves most of the community out. And with this long release cadence, there's minimal or no feedback loop from developers to users. And BPF really helped to break this long cycle here because it managed to decouple from kernel releases. Just think about, for example, Cilium, when it installs its networking programs, we don't necessarily care too much around the kernel versions. What runs on older kernels can also run on newer ones, and it can bring this change instantly just by upgrading Cilium itself, but not the kernel. Number two, BPF allows to shift data processing closer to the source, freeing up resources. If you think about traditional networking functions like load balancer, firewalls, etc., they are on a per packet basis. This comes more like traditionally from the hardware style processing that has been moved then into software. But it can be expensive, as in particular on generic layers of the kernel where every packet needs to be inspected and modified. But if we reframe the original problem by moving further up or down the stack, essentially closer as close to the source as possible. We also get more OS context around that. And BPF allows really to shift the networking processing into the socket layer, or into C-group layer, or really down into the driver, into the express data path layer. And that really helps to significantly save costs because of that. Number 3, BPF allows for shorter production feedback loops and location-aware processing as well. If you think back, like if you run your own kernel into in your fleet, if you have that luxury, and if you let's say, for example, want to experiment with congestion controls in order to optimize this for your data center, it's a long feedback loop, because you need to patch that kernel, you need to gradually roll it out to deploy the change, and only then you can start experimenting, collecting data, and then you need to start over. It's like an iterative process. It's long, fragile, because traffic needs to be trained from nodes. Nodes need to be restarted. You're unable to move fast. And the same principle of the decoupling from the kernel version, it allows for much faster updates of the program, and this shortens the feedback loop. Number 4, BPF enables to move traffic with significantly lower latency. So that allows essentially to implement node local forwarding infrastructure for data center workloads with the TC BPF layer in particular. The usual traditional way is to move, like when packets to and from the pods in the host namespace is usually going through upper layers of the stack, and because of that, some of the information on the packet is lost. If we can retain all of this in the TC BPF layer, we can do all the forwarding in a low layer, and with that, information can be retained from the packet, such as the packet socket association or egress timestamps. And the whole theme around this is to get host native performance for pods, for network namespaces, essentially. And this really helps around the feedback for TCP. It helps TCP pacing, BBR, which is based on top of that, and various other things. And this all ties into reducing buffer bloat, not only for the host, but for pods in particular. Number 5, BPF provides building blocks from the kernel instead of just reinventing the wheel. And that really, the perfect example around this is the FIP lookup helper, because it allows to reuse kernel routing and neighbor tables. All of the user space BGP stacks, they can transparently be reused, because the routes can be installed through netlink into the kernel, and BPF from a fast path, for example, out of the XDP layer, has the ability to just look up the existing kernel routing tables, and you can build high performance routers with that. Going into number 5, it provides building blocks which are otherwise too complex for other kernel subsystems. For example, NetFilter never had a NAT4.6 and 6.4 translation possibility. Typically, the IPv4 and IPv6 code base is very complex, and a lot of the packet representation, from the SKB in the kernel, it contains address family specific data, and it's hard to change, hard to manage. There are some existing out of kernel tree modules around NAT4.6, 6.4, but they never made it upstream. They all had the limitations. We implemented this with BPF, and it's, I would say, reasonably straightforward around XDP, because there's no context. It's in the earliest possible layer. It can just be done through rewriting the packet and push it back out, for example, for gateways. Around the TC BPF layer, there's a small helper which changes the metadata around the socket buffer, and the rest of the rewrites that are done in the BPF program, but it's definitely possible and easier to do than in other subsystems. Good example around this is also Android. So they use this today on your phone to connect to IPv6 only cell networks. Number 6, BPF to some degree at least allows to fix or mitigate kernel bugs on the fly. So there was a good example earlier in this year around that, where we fixed the kernel bug inside the Weave driver, and that actually affected on AWS the physical devices transmit queue selection. There's a good talk around this tomorrow from Laurent. All your queues belong to us. I recommend you dial into that as well. And that helped to avoid complex rollout of new kernels. And this time it was out of the user's hand. So even if the infrastructure team don't build their own kernel, then you need to wait for the cloud provider to actually pull in the stable fix and to update it. And like this, you can just do a change in BPF and restart the application, and that's it, right? Then the bug is fixed, and you can plan a proper upgrade later on. The other thing that is less talked about is resilient receive processing to actually reduce the attack surface of the stack from bad actors. Good example here is flow dissector, which can be implemented or partially implemented in BPF and XDP to help to drop packets early that would otherwise cause a packet of death type scenario in the upper stack when it does complex packet parsing. Number 7, BPF allows for low overhead deep visibility and enforcement into the system. So I could probably do like a whole hour talk about this topic, but essentially the gist is that, you know, for your cloud native environment, you can run the BPF collectors on every node, and they gather interesting data. And then they can be pushed into a store and then visualized through nice dashboards. So I think that's super interesting. There are many projects around that, in fact, already. The other thing is troubleshooting production issues on the fly, especially in a safe way with BPF. There are a good number of BPF trace examples around this, and it provides richer visibility than the old style perf. Another example in tracing and security enforcement that we can do, I posted here like a configuration around Tetragon where it can kill processes that would create unprivileged user namespaces. So that's a possibility. The other one is, you know, the data export into GUI dashboards where you get the visibility in a nice way and can inspect your cluster in a deeper level. Number 8, BPF decouples from legacy UAPI and allows for efficient data processing. So traditionally in the kernel, things had to be extended and oftentimes touching the fast path, where the feature itself may only have been applicable to a small subset of users, but BPF allows to keep the fast path to minimum and actually fast, because it decouples if users have to solve a complex problem, it can just be done in BPF without actually affecting the kernel's UAPI that it exports, right? And they are building helpers, building blocks like helpers maps and they even decouple the entry point into BPF. So the entry point to keep that efficient is the most crucial one, and everything else is then up to the user to implement. In the case of, just to provide an example here, the whole queue proxy replacement we built around BPF, so it's possible to build a fully conformant, even more efficient and customizable thing with just the BPF compared to NetFilter. Number 9, BPF is an enabler to build policy enforcement features around stronger notion of identity. So that's the whole core around abstracting away from this high IP churn in crucial Kubernetes environments. So IPs, they become meaningless because most of the pod configurations in Kubernetes, they are centered anyway around pod labels. And the other thing is, you know, the general pod lifetime is becoming shorter, so there are ephemeral workloads. BPF helps you to build policy around labels in an efficient way, and also to build things like egress gateways where you move away, where you can build like more stable IPs which can then connect to the outside world, or like to the rest of the environment, where, for example, ACLs are hard to update or to keep up with this churn. Number 10, BPF allows developers to extend the kernel, but with a safety belt on. I think that's probably the most important feature where the BPF brings to the table. If you think about developing kernel code and developing the same code actually in BPF to say the same functionality, the cost around the BPF is much lower, simply because of the built-in safety from the verifier. It helps to troubleshoot production environments, which can be stressful, but with the safety belt on, it's easier, and it's easier to debug things. Portability can be achieved for BPF modules across kernel versions. There are built-in features into BPF such as Cori, BTF, and so on. So BPF really becomes a flavor of the C language that is a better and safer choice for programmers. There's a good example that has been shown at LPC, where like a code snippet that is okay in C, but not okay in BPF-C, because the verifier also takes type information into account. And if there's no safe access that is determined, then the program is simply rejected. So what comes next? Around the BPF core, we will see more building blocks and lower entry barrier for developers. We're already on our way to support 100% of C in a safe way. Use cases are typically production need driven. So whenever something comes up that needs to be solved, typically also pushes the boundaries of the BPF core. So we extend the infrastructure around that. For example, that what will be possible soon is to implement data structures natively with BPF, or to have programs at early boot time. Just to provide two examples. The other thing is cross-platform support and standardization. So eBPF Foundation is working around providing a BPF specification. Number two, signing is a big topic in BPF. So the main goal is to attest the origin and to verify if the source is actually authorized to run BPF programs. Whole goal is to keep bad actors out, while also clearly identifying the actors that are using BPF, the good actors. The challenge here is to that a vast majority of programs in the ecosystem are actually of dynamic nature. For example, just think of BPF trace, and signing only static programs would lock out the vast majority of those users and would break those. So that's definitely a no-go. And there are various approaches in the discussion. There's no good one-size-fits-all type solution for covering all of them. Right now, what we are approaching towards is a gatekeeper BPF program that can be hooked into the verifier at various points to do the signature verification, and then reuse the in-kernel key management facilities for that as well. And the other one is the signatory service for the BPF ecosystem in order to solve this dynamic nature of the programs. There's definitely also high interest from not only Linux, but also the Windows community. Next topic is the increased focus on profiling BPF with BPF. So the more components in your cloud native environment are run with BPF doesn't automatically mean it gets faster. For example, badly written programs, they of course can cause performance regressions, cache misses, and so on. So more visibility and the profiling eBPF becomes increasingly important. There are already some work around this, some initial tools around that topic, but we'll definitely see more, for example, code coverage for BPF programs. Cloud native environments, they see even bigger adoption. So I think similar as Kubernetes fans out into edge environments, so does also BPF. BPF also already gets implemented for 5G data planes. We see it in IoT security enforcement environments, but there's more coming around APMs, security monitoring platforms, not only load balancers, but also gateways into the cloud. There's a lot of potential around memcaches and accelerators. There have been some work in academia around that, but not yet some public or at least OSS projects. What is also really funny at the LPC conference recently, I overheard that XDP and BPF is actually already running in wind turbines. We'll definitely see adoption growing in more conservative environments, such as ISPs and telco environments, simply because XDP and AFXDP, together with BPF, they blend in more naturally with Kubernetes as opposed to, for example, frameworks like DBDK, simply because it's easier to configure, to use, and the context is already in the kernel. So when something has to be pushed into a pod, it's already in kernel space and doesn't have to be pushed from user space back into the kernel just to reach sockets. There's also a lot of interest around BPF and SRv6 for traffic engineering. And if you think about the initial Gartner statement with regards to Kubernetes mainstream adoption, the more users are migrating towards Kubernetes, also BPF solutions piggyback on that because they are already the preferred choice or default today. And there's a strong and continuous growth of existing, but also new areas. So there are new use cases on the horizon, such as the process scheduler, where 3 companies are actually working on that. BPF for file integrity monitoring and system to monitor system software and applications as well is interesting. A lot of the potential BPF also has around storage. There are some early discussions around that in work, but I expect more to come in this area too. More longer term directions, so BPF usage as safe and portable kernel modules. There are some users already that set precedents here. For example, the human interface devices that are being merged right now as we speak. But once that happens, I definitely expect other areas as well to where this grows. Live patching could be an opportunity that's a bit further out in the future, I think. But what I also think from project side that is really interesting is projects like Kepler that already use BPF to export power consumption data for Kubernetes clusters. I think that also is really interesting to later on tie this into other layers as well, such as BPF process schedulers. So I think there's a lot of new things and exciting things to come in the future. And with that, I would like to thank you and open up for questions. Thanks.
Awesome. Thank you, Daniel. It was an incredible presentation. One of the pieces that I really took away from that was that idea of basically collapsing the abstraction between applications and the Linux kernel, like basically making it so that you have, how much more eBPF opens up in that space, like, understanding the difference between the two, or I guess collapsing it. We have a few questions from our audience. The first question, please. We have Nate asking, part of the dynamic nature of cloud-native environments is that nodes come and go, etc. Applications frequently restarted, etc. And does eBPF help with this dynamic type of cluster?
Yeah, absolutely. So first of all, so eBPF is the tool itself, and then what people make out of it is in their applications, such as the projects we have around eBPF, and they of course can make use of the means that eBPF provides, as I showed in the talk, for example, to provide to allow for upgrades without disruption of applications, and that definitely helps, as opposed to, for example, rebooting nodes and then restarting services and so on, right?
Yeah. Our next question. How has the adoption of cloud-native technologies affected eBPF development itself? I like this one because in some ways it's an interesting question because you work at Isovalent, you work on Cilium. So I imagine that there's at least some portion of the work that is going into eBPF that is like being kind of pushed on from that direction.
Yeah, definitely. I mean, like in the initial years, like 2013, 14 onwards, like it was just a small community in the Linux kernel around eBPF and just a handful of people contributing to it. And now like it has exploded. So as Alexei showed in his earlier talk, now we have 50 to 70 emails with patch contributions a day that we go through and review. And it's really awesome to see. And a lot of times, the use cases that we try to solve, they tie into the cloud native world. And because of that, we can also, it also encourages people to extend it and then, bridge this gap from kernel community into Kubernetes community and so on, so that everybody can benefit from it.
Nice. Question number 3. Is multicast forwarding supported by XDP natively? Now, this is an interesting question.
So it's not, because right now there's no means where you can duplicate packets and then push them out the interface. It might come in the future, or otherwise you would have to do this as a slow path operation and push it up the stack.
But you'd be able to see, I mean, like I remember was instrumenting something so that we could actually measure the performance of, maybe in the network device, the performance of that packet duplication, or like how long it's taking latency wise for things to actually get across the stack, and those sorts of things we can measure with BPF, right?
Yeah, absolutely, and that's possible.
So observability is there, but like the packet duplication, certainly probably an ASIC will always be faster than that, than the Linux kernel likely. What's our last question? Just Split asks, was that hotfix developed by the customer or by the cloud provider? I think referring to the hotfix that you had mentioned in your talk.
So there will be actually details in Lauren's talk tomorrow, but essentially we worked together with him and we actually fixed it on the kernel side, but we also did the fix in Cilium, so that basically the only change that was needed was to upgrade Cilium, then it was fixed. Regarding cloud provider, I have no idea whether they eventually backported this to their stable kernels, but I presume so because it was quite a large one.
Nice. Well, awesome. We'll definitely stay tuned for that talk tomorrow. Right now, we're going to go over to Tracy to introduce our last keynote of the day.
All right, as Duffy mentioned earlier, and as we've been saying all day, put your questions in Slack. And I think you're going to be happy about this one because not only is it our last keynote of day one, you better come back tomorrow. It is a talk from Purvi, and it is eBPF and Cilium at Google.
Thank you, Thomas, Liz, and the entire organizing committee of eBPF Summit for inviting me to speak. Let me start off by introducing myself. My name is Purvi Desai. I'm Director of Engineering at Google Cloud Networking. And I'm very honored to have a chance to talk with you all. However, I'm even more honored to talk about today's topic. We have wonderful teams at Google who work in these areas of today's topic, and I've learned a lot from them while collaborating on products or even while preparing this talk. So I'm going to start off by thanking them for the insights that I'm going to share today. So I'm going to talk about eBPF and Cilium at Google, and I'll cover it in 4 parts. First, a brief overview of eBPF in Google. Second, I'll walk through the journey of Kubernetes networking at Google, leading to eBPF and Cilium adoption. Third, we'll cover learnings, challenges, and our vision. And at last, we'll end with some ask for this larger eBPF community. Okay, so we love eBPF at Google, period. Let me explain how. We participate in community. Almost 25% of kernel reviewers and maintainers for eBPF core are Googlers. And that says it all. We have experts in Google specializing in eBPF cores functionality such as security, networking, resource control, and observability. We participate in committee. We have Googler who sits in the steering committee of eBPF. The responsibility of the steering committee is to make sure that the core of the eBPF is well maintained and to set the roadmap of eBPF development. We have massive and wide range of adoption. Google uses eBPF for a range of applications in production, from networking, compute, telemetry, security, and more. In this summit itself, we have Googlers presenting on container-oriented observability. And in public domain, you will find talks on kernel runtime security auditing, on eBPF-based CPU scheduling, networking resource control, and so on. We have adoption at Google scale. So we have eBPF programs which are installed on millions of machines, and almost all Google traffic is touched by an eBPF program in one form or the other. After migrating applications to eBPF, we have been observing improvements too. For example, one such improvement is around 50% reduction in latency for a similar function implemented in a different manner. While we can talk about this at length, and we can invite those experts in Google to talk about them, for today I'm going to dive into Google's Kubernetes engine's journey to eBPF. So Google open sourced Kubernetes in 2014. And with open source and Google's Kubernetes engine becoming generally available in 2015. In early releases, the concept of services and cluster IP load balancing was introduced, which was eventually implemented with IP tables. Later on, network policy implementations were done through IP tables. Since then, Kubernetes made huge inroads, And at Google, we continued our contributions to open source and also continued to offer differentiated and fully managed GKE with deep integration in GCP. Then we launched our Anthos managed platforms, which enables customers to run their applications anywhere on GCP, in their data centers, or in other clouds. From networking, we needed tons of flexibility, features, telemetry, security, and we knew that IP tables had run its course. From the very early stage, we saw eBPF and Cilium's disruptive paradigm that exposes programmable hooks to the network stack inside the Linux kernel. So when the time came to decide on next data plane, after due diligence, we unsurprisingly chose eBPF and Cilium. So eBPF and Cilium because of three reasons. First, eBPF had all the functions that we needed of programmable hooks in kernel and ease of operations. Second, we had vast expertise in-house with eBPF and networking. And third, because of eBPF and Cilium's maturity, leadership, and active community. We saw the potential of being able to contribute and extend it for our customers. We launched GK Data Plane version 2 based on Cilium eBPF in 2020. Since then, we have made this generally available as Data Plane Foundation for GKE, Anthos, and our newly announced platforms, Google Distributed Cloud, Edge, and Hosted. It is also now default on our innovative GKE Autopilot offering. Since the first launch of Data Plane v2, we have been able to deliver multiple features on this platform and launch more platforms with the same consistency of feature set. So let's go over some of the benefits that we have seen through this data plane and our customers have seen through this data plane. One of the not so hidden superpowers of Kubernetes is its developer-first networking model. Data Plane v2 is an opinionated, fully managed, Kubernetes-compliant network stack, which is based on Cilium. So we have harnessed the power of eBPF and Cilium. Consistent experience. One of the most important benefits for users is the consistency of experience. And we have delivered the same features, functions for Anthos, GDC, and GKE, but without lowering the bar to the lowest common denominator. So we have leveraged the Kubernetes style extensibility and pluggability to take advantage of advanced features where they exist. This enables us to have deep integration with GCP for GKE and flexibility on Anthos and GDC. For example, on GCP, we have container native VPC, Kubernetes native load balancer integration, Kubernetes native telemetry. On Anthos and GDC, we have huge flexibility. Third benefit is customization. In order to meet customer needs, we have been able to quickly turn around with customized features or customization in data planes to introduce new adjacent features. This was possible due to eBPF and Cilium stack. Few examples being insertion of Anthos Network Gateway, enabling BGP load balancer of flat IP on Anthos, or network policy log annotations with Kubernetes and GCP on GKE and other platforms. Fourth benefit is the feature velocity. With eBPF and Cilium, we were able to add features at rapid pace for Anthos, GKE, and GDC. For example, egress NAT gateway, or redirect policy, Cilium scalability, IPv6 improvements, such as NDP. And now we are working on introducing multi-network in Kubernetes so that enterprise or network functions or telco workloads, which need multiple interfaces, can take advantage of Kubernetes abstractions. And we have continued our contribution with Cilium open source by upstreaming the listed work as we've added them for our offerings. Finally, the benefit is of ease of operations. We were able to provide fast updates with ease without needing kernel upgrades or sidecar upgrades. In summary, with Data Plane v2, we harnessed the power of eBPF and Cilium and Kubernetes. So Google has been committed to open source Kubernetes, and now even to Cilium. We are quite happy and proud that Google was the first cloud to adopt Cilium, And our strategy has been validated with tremendous customer feedback. So we have listened to our users very closely. Our users love opinionated and managed services. We have seen significant interest in migrating away from IP tables and harnessing more power towards flexibility, observability, security, and supportability. We are seeing solid adoption of this data plane with our fleet transitioning to this data plane very rapidly. However, we also have customers who want the freedom and the ability to pick and choose from an open source ecosystem and enable from the best of both worlds, which currently could be challenging without enough modularity in the underlying layers. So we see the need of power of and not or. So we believe we can achieve this by bringing more modularity, pluggability, and composability to Cilium and data plane v2. And we will be investing in this area in the journey ahead. So in the journey ahead, we plan to continue and magnify our commitment to Cilium open source. We will be upstreaming new innovations required to support edge, telco, enterprise workloads, and also ensuring that there is a tight loop coordination between Cilium and Kubernetes, as for us, Kubernetes compliance is a key criteria. We have already started investing in enabling more modularity, pluggability, and composability to Cilium and data plane v2. Our North Star is that GKE is a dynamic and open ecosystem of innovative networking features. We are very excited about the journey ahead. And while this journey of dynamic ecosystem is very exciting, at the same time, it is challenging. There are places where even the underlying eBPF technology is not sufficiently there. So we thought it would be great to pose some of those asks to this larger eBPF community, which, by the way, includes us as well, and hence it applies to us as well. Here are a few things. One, concept of ownership of installed eBPF programs. It would be great to know which process has installed what. On the same line, ability to have eBPF program registry. Some way where we can obtain metadata about installed programs. Who installed it? What else have they installed it? What maps are relevant to this eBPF program? And so on. Continuation of that would be ability to put policy on programs. A way to classify or restrict what type of programs are allowed to be installed by particular processes or users. And finally, ability to chain multiple eBPF programs on the same hook. Now, while we would be looking forward to such enhancements, we are going to continue on our modularity journey through Cilium modularity. And in the end, let me summarize that we have healthy love for eBPF at Google, and it is seen from the Google scale adoption, participation in community, and we have a great start of eBPF and Cilium in Google's Kubernetes engine with a rapidly increasing footprint. For this, a very big thank you to the larger eBPF and Cilium community for the progress thus far. And we are very excited for what is to come in the future and our collaboration. Thank you.
First off, I need you all to know how much we've been geeking about that production value of that video. So I'm pretty sure everybody out there is also geeking about that. That was a great presentation. Thank you so much. And I particularly enjoyed the benefits of the data plane. I like breakdowns like that. That helps my brain.
Can I tell you that I really didn't want to do that professional recording. And I said, please don't make it look professional.
But there
It
were
was
some issues, so I had to go for that. But thank you.
okay.
I'll let
I don't
them
think it
know.
was overly professional. Yeah, it was like nice and clean, but it came through very, very well. So thank you for that.
Google. Thanks
All
to
right.
Google. Thanks to Google.
Awesome. All right, let's get question 1 on the screen. So we have, does Google use XDP2, since you said eBPF has been there for quite a while, for maybe an even lower level control?
Yes. So in a way, we are right now. So Google, first of all, is so big, and we have usage of eBPF across entire company, which sometimes it's very even hard to kind of put together in one answer. But let me respond to this from the Kubernetes networking perspective. Okay. And right now, along with many other teams within Google, we are looking at XDP-based applications, supporting the applications which needs XDP. And we are bringing that support in. We are starting with network functions or the telco workloads and those kind of requirements to begin with. And then we will see how far it goes.
All right, awesome. All right, let's bring that
But
next
by the way,
question.
we are very excited about, sorry, I wanted to just say, we are very excited about that you productionizing XDP. Right now, we think this is going to be a game changer for us.
Crossing my fingers. Yeah. Let's bring on question 2. Thank you. All right, so where is Google's use case with multi-program supports? I assume Google's use cases will push supporting chaining multiple programs.
Yes. So I think this kind of covered as my wish list in the talk at the end. Yes, we are running into exactly this use cases where we need to be able to run different programs on the same hooks, or mix and match the programs, because we do want to make sure that customers have ability to pick different functions depending upon where they are. So it is going that path. In the beginning, we are right now working with Cilium team for modularity, and large part of it is going to focus from like a service chain and all of that. However, having that support in eBPF would be a great, I would say it would be a great strength for us.
All right, engineers, you heard that request, having that support in eBPF. I'm just saying. Let's see. I think we have 1 or 2 more questions. What's our next question? Joe, what's the status of Hubble observability in Data Plane v2?
That's right. We discuss about this almost every second day recently within Google too. Okay. We are working on it. That is a short answer. And we are also working with Cilium community on this because there are some nuances that we have to work through, but this is something that we think is a ask of our customers, and we are working on supporting it for sure.
Nice. And I think we may have 1 more. Let's see. We may not. Nah, we didn't. Okay. However, I do know in the thread, there are a ton of other questions that are just waiting. So if you all have any other additional questions that you want to add, go into Slack and do that. Did you have anything else you wanted to add before we finish up?
No. By the way, I want to just thank you all, the entire eBPF Summit once again, Summit organizers once again, and all the entire community of eBPF. We are very excited with where eBPF is going, and based on that, where our data plane is going, and even more than just networking. So thank you.
No, thank you. We're just as strong as our community, and we have a nice community, and we have people like you in it. So, hey, that's what it's all about.
Yes.
Thank you so much. I appreciate it.
Wow.
I survived.
We have survived. We're on the other side. I'm excited. We have another day and a day of things tomorrow, but I just wanted to reflect with you about like how we did today. Like, what did you learn? What were some of the takeaways and how that went?
I learned never to listen to you in the background before I
okay.
have to go on screen.
Oh, okay. All right. Fair.
Okay.
Not sure what I said. But, you know.
No, actually, I need to go back. Like, you know how you've looked at stuff and then, but you haven't actually had a chance to like look at it. And so the things that I know some people think when people are hosting and they just give like one or two tidbits before they like introduce the next person when they're thanking. I don't do that just to have something to say. Anything you heard me talk about after like the lightning talk or a note when I said thank you and thank you for explaining, I literally mean those things. So those are notes that I can have now, like after tomorrow when we're through, and go home and then get back to work and bug you and Liz and Joe and the entire crew and go like, I think I got this, but like, what exactly did they mean? So I haven't really absorbed all of the talk yet, but I'm definitely taking notes and I'm really enjoying myself. I was scared, but I was enjoying myself.
Yeah, I agree. And I mean, for me, you know, like last year, I think, you know, the back of my brain is still processing everything that I learned today. There's been a ton. You know, some of the talks that really stuck with me are things like the eBPF, the capital markets perspective, which was talking about where eBPF is kind of, I mean, not it wasn't like directly related to like where it is in the hype cycle, but that's another way of thinking about it, right? Like, you know, like, is it the right time to invest in companies that are involved in the eBPF space, and like how do they measure that? And like, it was really kind of a really fascinating talk. I also love to hear from Dave Thaler, and I loved so many of the talks. I think, gosh, design-wise, everybody's talk like had a different characteristic or a different feature that I really liked. You know, like Martinez's talk with him outside. He was sharing anecdotally that like when he was recording, like sometimes like a farmer and their dog would like go by behind him, you know. And I thought I was like, you should keep it. It's beautiful.
It should have been in the video, yeah.
All of our amazing watch parties. It was great to see that. I hope that many of you actually have counted some of the EBs that are happening. Remember they didn't all show up today, right? Some of them will be with us for tomorrow. So we have a couple slides to share.
All right, let's see what we got. I think this is you.
So this is a reminder that there are still 2 challenges left in the capture the flag, and if you solve it, make sure that you go ahead and upload the flags that you see, and so that we can know that you have solved one challenge or the other as you go forward. A reminder not to put any spoilers in the eBPF Summit channel, but put them instead into the eBPF Summit CTF spoilers channel for people who would actually like to consume those things. And if you want to participate in it, go ahead and go to isogo.to/CTF2022.
Yes. Now, I know I'm not supposed to have a favorite watch party, and I asked to share this one because I thought this was the most awesome thing I've ever seen in my life. So, absolute shout out to the Infield Watch Party because they seem like a very sweet and lively crowd. And based on the bee that I see in the watch party, they've been playing bingo. So,
that's right. They are playing
I
bingo.
need you all to make sure that you are watching out for those bees because they are probably in places that you least expect.
That's right. Exactly.
And then finally,
so we have talked a little bit about our wrap up here, and we've talked about day 2 tomorrow. So day 2 tomorrow, we're going to come back and we're going to see a keynote by Margaret Mantarola talking about buzzing across the eBPF landscape into the Hive. She has joined us here at Isovalent. It's very exciting. We also have All Your Cues Are Belong to Us. You heard Dan Borkman refer to this talk in his talk. Definitely a good one to catch. It's going to be really good, by Laurent Bernal. Then we have our eBPF security section, which will include 6 talks. We will be doing a live solve of CTF number 2, where I will be trying to solve it while Liz pokes fun at me, and we go through all of that. And we have a bunch of talks, lightning talks, and regular presentations on eBPF programming and internals. So if you would like to get involved in writing eBPF programs, this is going to be your place to jump in. And then we have our wrap up. So thank you all for your attention today. I know that was a lot of content and a lot of information, and I look forward to sharing even more content and even more information with you tomorrow.
Yes, I will see you all. Make sure you have a cup, a backup cuppa, and some snacks because we're going to have fun tomorrow also.
That's right.